So, sir, we have total 103 participants right now connected, sir. So, shall we start?
Yes, we can start.
Okay, sir. So, good morning, all. So, on behalf of all the organizing E and ICT academies at IIT Guwahati, NIT Patna, MNIT Jaipur, IIIT Jabalpur, IIT Roorkee, and IIT Kanpur, I welcome you all in this 8-day of a 2-week long joint faculty development program on Internet of Things and applications in smart systems. So today's first lecture will be taken by Dr. Argyadeep Roy, sir. So we already know him. So with no further delay, I would like to invite him on the platform. Over to you, sir.
Thank you. Thank you for the introduction. Good morning, everyone. So today the topic on which we are going to spend some time is basically smart farming and how IoT is useful in doing that. So I hope in the last two lectures, in which I taught communication technologies in IoT, and the second one was smart home applications. Those were useful for you. So before starting the smart IoT smart farming, let's go over quickly to the last two lectures, so that if you have any doubt, because some of the concepts might be useful in this lecture as well. So if you have any doubts, please feel free to ask or post in chat. Okay, so I'll start with the first one. So are you able to see communication technologies for IoT?
Yes, sir, we can see it.
Okay. Okay, so in this talk, we talked about some communication technologies such as Bluetooth Low Energy, LTE-M, NB-IoT, and the comparison of this. So now, based on the last two talks, what you can see is basically there can be two kind of scenarios. One is like the IoT network is also operating in the licensed frequency band, which is basically the 3GPP provided frequency band for the cellular communication, and also it can operate in unlicensed frequency band, like for example Bluetooth or Wi-Fi and so on. Okay, so on unlicensed frequency band, there can be a problem because if you want to use cellular resources, there can be a agreement there. There is a need of agreement between the cellular network and the IoT network, right? So that may not always happen. So in the second lecture, we have seen a coexistence scenario where like we have considered a like IoT network which is not deployed in the cellular setting. So therefore, there is a concept of cooperative relaying. So in the cooperative relaying, what is happening is basically the cellular networks are using the Wi-Fi, using the IoT access point as a relay, and the IoT access point is getting benefited by using cellular communication by uh, by providing by because cellular is basically able to give them quality of service guarantee. Okay, so they can use the TDMA structure, those kind of structures that is available in the cellular communication. But unfortunately, in the Wi-Fi communication, it is contention driven. In the license band, it is contention driven. Okay, so in this talk, we have covered some of the technologies like LTE-M and NB-IoT. Those are basically relevant in the context of licensed frequency band, okay, in the cellular communication. Okay, so these are some of the communication criteria like range, um, frequency band, power consumption, topology. And these are some of the technologies like Bluetooth. If you want to set up a short range IoT based network, you can use Bluetooth based communication system. For a medium range IoT network, you can use Zigbee, Wi-Fi. These are the 802.11 AC, BG, and AH. So they typically work in 2.4 to 5 2.4 gigahertz or 5 gigahertz. I think in the later part of the talk, you will also see there is a separate session on 5G based IoT. There you will see probably the use of millimeter waves in IoT based communication. But again, millimeter wave has certain trade-off. That is, millimeter wave typically has a good LOS. When you have a line of sight situation, then it will give you a good throughput, but its range is typically small. So if you want to use millimeter wave for your IoT communication, it will be a short range communication, but the throughput will be very high. Okay, and in the long range, mm, in the long range communication, 2G, 3G, 4G, 5G, those are also applicable. So when I talk about millimeter wave, typically the range will be short range, but there are other frequency bands also associated with 5G, okay, which is known as 5G NR, new radio. So excluding the millimeter wave part, that typically works in the frequency band, which is 4G frequency band only. So therefore, those kind of systems can be used for a long range IoT. Okay. Now choice is yours, based on your based on your use case. You want to choose that which kind of communication you want to use. So when you think of agriculture, typically it may happen that you are deploying a lot of IoT nodes within a field, within a very big field, and then based on your range requirement. Okay, so for example, if you want to do it in a centralized fashion, so, for example, there are certain controllers present within in the middle of the field or in the edge of the field, and there are sensors present everywhere. Then it may require a long range. If your field is too large, then it may require a long range communication. On the other hand, if you use a if you want to control a small field, or you want to communicate in a distributed fashion, for example, there are many IoT sensors that are deployed within the field, and then they want to communicate with each other. In that case, it will be like a Wi-Fi based communication can be used, because typically it is short range. Okay. Okay, so Bluetooth is one of them. In Bluetooth, it's an important short-range communication technology. It uses 2.4 gigahertz, and typically it is used for wireless speaker and headphone. But contrary to like normal use cases in Bluetooth low energy, the requirement is little different, because it will have small data in regular intervals. It's not like a huge amount of data, and you are sending it in a streamlined fashion, like the normal Bluetooth application, where typically you are listening to a Bluetooth speaker, and then you are using YouTube. Okay, so therefore the requirements are a little different, and that way it uses frequency hopping, speed spectrum, and frequency shift keying, and the range is typically 50 to 150 meters. Okay, so these are some comparisons. We have already talked about this. Along the long range technologies, there are 3GPP and non 3GPP standards that we have talked about. So in this talk, we discussed LTE-M, NB-IoT, these things. And in non-3GPP part, there are technologies like LoRa, Sigfox, etc. Okay, so LTE-M is a category M1 standard published by 3GPP in 2016, and it requires a new baseband software in the current LTE architecture. Therefore, the number of changes required in the current LTE architecture is very minimal. Okay, so that's a good point. Okay, it is a power consumption mechanism. It can go to sleep when it is not in use, and there is something called extended DRX that is used for this purpose. Also, its coverage is good, and it's a better penetration, indoor penetration than LTE. Okay, so yeah, latency is 10 to 15 millisecond and so on. Okay, these are some of the applications like energy consumption, water, natural gas. Okay, this kind of monitoring you can do using this LTEM. Also, there are applications involving smart city, checking for parking lot availability, intelligent public lighting. So when you are walking on the street, and then lights are getting on and off based on your location, those kind of applications you can use LTEM. Okay. So there are, yeah, these are the applications: healthcare, asset tracking, wearables, smart city, smart meter. In the narrowband IoT, we talked about WebDMA link in WebDMA in downlink and SCFDMA in uplink. It is just like an LTE, okay, but it operates in a very narrow band because the frequency associated is like 180 kilohertz, okay, which is like one resource block in LTE. So it operates in a very narrow frequency band, and there are three possible operation mode. One is standalone, there is guard band and in band. Okay. So in the standalone mode, cellular services are not present. Okay, so when 4G is not present, what we do is we typically use GSM. We reframe the GSM bands in such a way that it is allowed to, it matches the specification of NB-IoT, and that way we transmit the data. Okay. And also there are guard band mode where cellular services is in the left hand side, and there are in band mode where it can use along with the like usual spectrum. Therefore, I mean there can be a potential interference. So these are the kind of issues that will be very prominent in the literature, that if you work in an in band mode, then how can you handle the interference of the existing LTE if they are operating in the same frequency band. Okay. Guard band does not have the interference problem, but the problem with guard band is it requires certain protocol change, right? Because the LTE protocol level, it is known that you will not transmit in the guard band, but when you go for NB-IoT, then you are transmitting in the guard band. Therefore, some protocol level changes are required. Okay, so yeah, so NB-IoT link budget is 20 dB additional to the 20 dB more than the GPRS link budget. Therefore, it has a higher penetration and battery life. Okay, and yeah, these are some of the features, and some physical channels which are basically a prefix N is added to the usual LTE channels like NP-RACH, NP-DCCH, NP-BCH. There is a broadcast channel, physical broadcast channel, and this is narrowband physical broadcast channel. So these are the counterparts corresponding to the LTE physical channels. There are power saving mechanisms like extended CDRX and IDRX, which is idle mode DRX and connected mode DRX. Okay. So there are many use cases where in one use case NB-IoT is better, and the other one LTE-M is better. We have already discussed about it. NB-IoT latency is more than LTE-M, but LTE-M is better suited for applications with very low latency, and NB-IoT is better suited where energy consumption is the main concern. So if you are looking for a green solution, NB-IoT should be your choice. Okay, yeah, some more references. Yeah, this is in the tabular form that both of them uses FDMA and single carrier FDMA in downlink and uplink respectively, but the bandwidth is different. As you know, NB-IoT is narrowband, so therefore its bandwidth is 180 kilohertz, which is significantly less than the bandwidth of LTE-M, and so on. Okay, so yeah, this was the brief recap of the first talk. Okay, so you have any doubt regarding this? You can post in chat. So,
So dear participants, you can ask your questions in the chat or Q&A section, or you can also raise your hand so that we can unmute you from the host end and you can interact in the session. Thank you.
okay, so yeah, so if you have questions, please post. Otherwise, we will move on to the summary of the second talk. So as you see that basically I'm just trying to make everything connected so that you have a overall connected flow of everything. So in the first talk we have talked about basically the nature of IoT communications from 3GPP side, and but in this talk we explored a different issue where the IoT network is not in the 3GPP band. Okay, so it is something else, non 3GPP band, unlicensed band. Then the problem is basically they do not coexist. Okay, you cannot just transmit in the licensed band because you do not have the possible collaboration between your IoT network and cloud network. Sorry, IoT network and cellular network. Okay, in that case, what you do is you do cooperative relaying, where the IoT network, the cellular network relay the data via the IoT access point and get access to the license spectrum, and cellular net and the IoT cellular network. Yeah, cellular network uses IoT as a relay, and IoT gets access to the cellular and get the QoS guarantee. Okay, so there are two kinds of approaches. One is this. The licensed spectrum network wants to do throughput maximization, and the IoT network do task computation rate maximization. So therefore, what we look for is a handshaking of spectrum sharing and mobile edge computing. Okay, so this was the scenario we considered. This is the IoT AP access point. The primary transmitter is transmitting via the access point relay and transmitting it to the primary receiver. So the primary receiver is getting signal from both two paths, and there are IoT devices that is connected to the IoT AP, and it is using decode and forward technique for transmitting this signal from PT to PR. Okay. So IoT AP helps in the PT in relaying the data to PR because there can be poor channel between PT and PR. This is known as cooperative relay. Yeah. So basically it uses a PDMA kind of structure where initially there is a protocol that initial tau hour by 2 seconds, the primary transmitter broadcasts to the PR and IoT access point. After that, IoT access point relays to the PR, and then there is TDMA offloading and parallel computation at the MEC cell. Okay, so so these are different phases of communication and computation. Okay, so if the slot duration is less than coherence time, that is the assumption, the channel gain remains same during a slot. Okay, and we use this formula for Shanna's formula for computing the relay. Okay, I think this formula is familiar to you. And then this is the local computation rate. So basically, we formalize the problem into a maximization problem subject to constraint like this. So constraints are like a guaranteed relaying rate, frame duration, energy limitation, and maximum CPU frequency. So these are some of the physical constraints that, and there is some relaying rate needs to be guaranteed, because if I do a cooperation, then the cellular communication technology should be benefited by that. Otherwise, there is no meaning of the cooperation. Therefore, the relaying rate should be more than that of without the cooperation. Okay, and the frame duration also should be finished. So the computation should be done within the frame duration and all that. So it is a non-convex problem. Therefore, we use some property of the problem plus some additional assumptions like all the IoT nodes tasks are identical and so on. And then we get a convex optimization problem, and the problem becomes like this. Okay, so the overall objective function remains the same, but the constraint, there are some additional the last constraint changes a little bit. Okay, so now this can be used since it is a convex optimization problem. You can use KKT conditions and Lagrange multiplier based techniques to find the final obtain the optimal parameters by solving a linear program. Okay, so these are some of the results which shows that if you do equal processor allocation, then your utility is much lesser than what you get if you do an optimal one, like the one which I presented, which is obtained by solving this problem. Okay, so the issue with this formulation is the number of IoT nodes are fixed. Therefore, whenever there is an additional node or one guy goes away, then you have to do the optimization problem again. Okay, so this is a static optimization problem. Okay, not the dynamic scenario. So those can be captured using machine learning based tool, because machine learning typically learns the rate at which the IoT users are arriving or departing. So reinforcement learning is a good tool to solve that kind of problem. Okay, so this was the summary for the second talk. Before I'll now move on to the smart farming part. Yeah, okay. So smart farming slide is visible. IoT application in smart farming. Okay, so we will talk about IoT application in smart farming. Uh, so how IoT can be useful in doing farming in a intelligent manner. Okay, so this is the brief outline of my talk. Initially, I will start with the introduction, then we talk about an AI-based system, existing solutions, proposed solutions, limitations, and conclusions. Okay, so so basically, to start with, the affordable systems to monitor and schedule agricultural activities are essential for efficient cultural practices, cultivation practices. So what does it mean? It means that whenever there is a big farming ground, then you need to allocate your resources and schedule the agricultural activities. So what do you mean by agricultural activities? First is irrigation, second is harvesting, and third is so one is irrigation, second is harvesting, and so on. Okay, so these kind of activities, like you need to give water the plants in an appropriate time, you need to provide them harvest them at appropriate time, and you need to provide fertilizer at the appropriate time. So these kind of problems are very necessary in traditional agriculture. There is no communication between different lands. So, for example, a particular farmer he may own a land in a very big, different, very wide area. Okay, so therefore it may not be uh, possible for him to go to individual things, or if there is a sudden weather change and some agricultural thing needs to be done, then also that is also not very useful. That is also not possible for a single person to do that. Okay, but IoT based communication will help in this case, because if there is a IoT network which can talk to other IoT devices, one device can talk to other devices and then propagate the news, or share some share some knowledge regarding the temperature, humidity, those kind of issues, then it is possible to do the cultivation practices in a efficient manner. Okay? So lack of such systems has caused problem, because this loss of soil, and it has resulted into loss of soil nutrients, increased dependence on inorganic fertilizer, water related disease, and depletion of groundwater. Okay, so if you do not do farming in an appropriate fashion, then the soil nutrient is lost, inorganic fertilizer dependence is increased, and groundwater level decreases, and water related diseases are also common. So these are some of the common phenomena we are all familiar with. Okay, so finally what it happens is the gross crop production basically decreases, and eventually it leads to farmers income, and basically those are the issues that in today's farmer are facing. Okay, so usage of IoT based system is a very useful technique to solve these problems, and we can develop certain machine learning based algorithms and implement them in the IoT system. Okay, because why machine learning is necessary? Because you need a lot of data. Okay, so you can use your past data. Okay, so a farmer, maybe he's experiencing similar kind of issues over a particular period of time, but because of his limitation or capability, because of his physical limitation or monetary limitation, he may not be able to take appropriate action in the upcoming year, even if the behavioral pattern is very same. Okay, so therefore what you need to do is you need to collect the data, and provide some futuristic prediction that what is going to happen, and that way you can optimize the system. Okay, so autonomous monitoring of cultural activities are necessary, so that you can use the IoT based system in an appropriate manner and in an autonomous fashion. It's like not dependent on his on individual physical exercise. Okay, so an AI-based system is basically an artificial intelligence-based affordable and autonomous system. So you can artificial intelligence-based system you can develop within a agricultural field, which can identify precise timing for various cultivation practices to increase the crop production. So what is the cultivation practice? One is irrigation, another is this like giving the pest control, or doing the pest control, or harvesting at the appropriate time. So these are the many different cultural cultivation practices which are necessary, and you need to identify the precise time for that. Okay, so so it will result in enhanced farmers' income, increased farm productivity, and wastage reduction will also be executed. Okay, so there is a report, okay, so which says that what should be the nation's AI strategy. Okay, so India as of now, it needs to produce 50% more food, and it needs to cater to additional 2 billion of people by 2050 compared to today. So compared to today, you need to serve 2 billion people additionally. So this is the goal. In essence, AI strategy report says all this, and doubling of farmers' income is also a national agenda. Okay, so if you basically want to achieve these goals, then what is the way you should go? And probably a combination of artificial intelligence and AI is a very good solution in this respect. Okay. So enhancement of crop yield would increase the farmer's income, and AI-based technology is basically able to do precision farming for fertilization and declining in the soil fertility and increased dependence on inorganic fertilizer for higher production. Okay, so these kind of solutions are the future in which the smart farming is moving. Okay, so poor utilization of water resources is a big issue, and it will lead to rapid depletion of groundwater level. Okay, so if my water utilization is not proper, sometimes you see that there is a lot of like rainfall, and because of which the crops are dying, and sometimes there is a lack of rainfall because of which also the crops are facing issue. But if the rainfall can be managed in some way, or if they can be channelized, or they can be if there is a sudden rainfall in a particular area, and if you can channelize that water to nearby places where there is less rainfall, or when there is a no rainfall, then if you can channelize water from some other places where there is a huge rainfall. So this kind of issues can be monitored or controlled, and defined different wireless devices in different areas. If they can communicate among each other using certain signals, then it becomes very easy. Okay, so farmer requires an irrigation system to precisely control and monitor. Despite having just one third of the gross production cropped under irrigation, the extracted groundwater is consumed 89%. Agriculture consumes 69% of the groundwater. Okay, so farmers require a system to facilitate precision farming, or basically they want to do these operations like harvesting and pest control in an appropriate time. And autonomous agents driven by AI-based system would be helpful in this respect. So here we are seeing a picture of a field which can be controlled using drones. Okay, so there are IoT devices that are spread, that are distributed, deployed within that field, and there are drones also. So drones, what it can do is it can basically capture the image of the field, and based on that, it can monitor the health of the crops, or the health of the overall ground, the water level, and it can monitor the temperature, etc. And very within a very short period of time, it can cover a very large range of areas. So IoT and drone-based communication both can be clubbed together. For example, in some regions where deployment of IoT devices could be difficult, in those regions you can sort of employ drone and uh, like um, get the data from the field. Okay, so water management, soil monitoring, and machines for routine operation, these are some of the features. Okay, so AI-based system, machine learning will help in analyzing and processing the data. So whenever you are getting a lot of data from drones or the sensors, this data need to be processed. The data needs to be fitted in a particular model so that you can predict that, okay, how my crop production is, it depends on the temperature or the humidity. So basically the crop production can be thought of as a function of multivariable function of temperature, then humidity, groundwater level, and for example fog, all these conditions will be there, humidity, and therefore in this using this kind of modeling, if you can propose certain function, if you feed the previous 10 years data, and then if you can propose a model, then it will be very easy, and the life will be easier for the farmers, because using this model, they can predict that what is going to happen in future. Okay, so usage of email based technologies is useful in this context, and it can be instrumental in increasing the crop production. Okay, so farmers take suitable action and timely action during various cultivation practices. Uh, okay, so for now we are going to cover some of the existing solutions. Okay, so existing solutions are there, which are typically uh, applying heuristic kind of solutions. Okay, but without any performance guarantee. Okay, so heuristic is basically an algorithm which does not have any performance guarantee, or it is not motivated. It is motivated from some intuition regarding real world phenomena, but there is no underlying optimization involved in proposing this. Or sometimes it happens that when your optimization, if you want to do the solve the optimization problem, the complexity of solving such a problem is very huge, then you typically adopt a heuristic method, which sometimes works well in a particular environment, but you cannot guarantee certain performance guarantee is not associated with a heuristic, and whenever there is a change in the parameter, they might fail miserably. Okay, so in the existing solutions, there are certain heuristic methods, but they do not guarantee any performance. Okay, so existing solution uses data-driven ML approaches. So what do we mean by data-driven ML approaches? So in machine learning, as we are saying that you take a lot of data from the past and build a model, and then based on that you predict the future or take appropriate actions in the future. But the problem is, in reality, a huge amount of data may not be available. Okay, so monitoring a field for a very long time, that is also the computation that has its own economical challenges. Okay, so therefore a huge amount of data from the field for the last past few years that may not be always present. Okay, so that's a big problem. And also, even if the data is present, you might question the reliability of such data, right? Because sometimes the observations are very noisy. Sometimes the instruments that are being used, those are not precise, and because of that, it is very difficult to build your model based on such a data. So then what you do, because even if it is available, the reliability may not be high, so it will lead to construction of inaccurate models. So that will be again that will be much more problematic, because if you build an inaccurate model, then since you are relying on that model, then it may happen that you are losing out on your production, like agricultural production, on multiple consecutive years before realizing that your model is basically not correct. Okay, so in that scenario, you can sort of go for a model-free approach. So what do you mean by model-free approach? Model-free approach is basically you do not take any previous data at all, but you interact with the system to come up with some interact with the system, and gradually you gather information regarding the field. So when when the environmental conditions like humidity, temperature, they vary a lot. Okay, so then basically model free approaches will be useful, because your data itself is a very stochastic in nature. So if you have a stochasticity in your data, then model free approach is good. But if your data is near deterministic, for example, if you live in an area where for 15 days, if you take a just 15-day window, the temperature, humidity, those kind of parameters are like very much similar for a particular time of day, then you can sort of, if your data is reliable, you can sort of build a model based approach. But when you are like living in an area where the data, where the temperature basically varies a lot, suddenly there are a lot of rainfall, suddenly there are a lot of sunny days. So then it becomes difficult because your environment is very much stochastic in nature. Therefore, if you want to apply this model-based approach, which are essentially meant for like static scenarios, then it may not perform well. Okay. So any doubts regarding this model-free, model-based approach? I'll just take a 1 minute pause now. Okay. So there is a question from Gulab Patel. I did not get the model-free approach. Is it decision taken based on intuition? No, it's not like that. So model-free approach is basically you do not rely on a particular model. So you learn the model on your own. You do not exploit the past data. So you just like so there are, for example, there are 5 actions that are available. You are taking a decision on every day. Okay, every day field you have to make decision. What that is, it is like end of season and the harvesting is nearby. Okay, so you have to choose either to continue, keep the harvesting, keep the field in the keep the crop in the field, or like harvest it. Okay, so that you can do is you can take the decision, take one decision and see what is the impact, how much reward you are getting. Okay, so that way you can sort of take many decisions back to back. So one day you take decision one, another day you take decision two, and so on. So by this way you get some data that okay, if I take this decision, this is my final outcome. If I take another decision, this is my final outcome. So in this way, you gradually learn that which decision is best for you. So it's a gradual learning process. You are learning. It's like kind of saying this reinforcement learning kind of approach where you gradually you do not want to. Yes, yeah, it is kind of RL where you do not depend on the model, but you learn the model by interacting with the environment. Okay, so does it answer your question? Yeah, I think you have got it. You asked kind of RL. So this is yeah kind of RL. RL also it can be model free or model based. In RL there is something called model based approach, which basically kind of try to estimate the model. But here basically you are avoiding the construction of a model completely. You just interact and then based on whatever outcome you are getting, so whichever action is giving you better outcome, you take it in the long run. Okay, so there was another question from Jenitha R, that is, what is the advantage of model-free approach? The advantage of model-free approach is since you are interacting with the field in a live, in on-the-fly fashion. Therefore, there is a very less probability of building an inaccurate model because when you have built an inaccurate model, you rely on it and you do not know that something is going wrong because you thought that you build a correct model. But here there is no risk of such things because you are essentially operating in a model-free fashion. So therefore, there is no possibility of building a wrong model based on past data because you are on the fly. You are dealing with them as and when the data comes. Okay, so this is the advantage. Any other doubts? Everyday manual intervention is required for decision making. So no, this is not very clear to me. Everyday manual intervention is required for decision making. No, I mean manual intervention may not be required because your decision making can be done autonomous fashion. But the features in which we are saving manual intervention is gathering the data. So these IoT sensors that are present, they will check what is the humidity, what is the temperature. They will sort of forward this data to some person sitting, for example, in a local panchayat office who is collecting the all the data, and some engineer, and he can take some decision, or it can be done in an autonomous fashion also. Ultimately, if you have to harvest, obviously some person should go and harvest, but when to harvest or when to give the fertilizer, those kind of decisions can be can be collected based on the reward of your past decisions, and then someone can choose it. So I what I example that I gave is a particular form of example, but in some cases the decision making might happen every 1 month or every 2 months. It depends on it may happen or twice or thrice a particular day also. Okay, so it depends on the use case. Okay, so does it answer your question, Jenitha R? Okay. Okay, thank you. Any other? Just let me check. Okay. So there are computer vision based solutions in the literature. For example, in this reference which is given at the end, the review of computer vision technologies are provided for automation, and so using machine learning algorithms and the vision sensors will collect data, and using those data it can build a model. So this kind of approaches are typically sometimes model based, but model free can be a future approach. Okay. Monitoring and measurement of crop growth, and insect detection, estimation of soil texture. Okay, so these are some of the areas in which computer vision based technologies have been used. Although I am not an expert in computer vision, so let's not go into the detail of this. But here, computer vision based technologies have been helpful. If you are interested, you can go and read these papers. The estimation of nitrogen content in the crop, management of irrigation, all these things can be done using computer vision and some machine learning, deep learning based technologies like neural network, artificial neural network, and so on. Okay, so some more techniques in this paper, they use a high resolution vision sensor, and the image segmentation is used. So you capture images of the field, different parts of the field, you capture images, and then you segment based on the health of the crop or some other pattern. You segment the images to diagnose the nitrogen content in the rice leaves. Okay, so these are low cost vision based AI technology. So basically, computer vision and AI basically the handshaking of computer vision and AI, they go hand in hand together, and then you can build system that can automatically weed and perform variable rate irrigation within a cultivated field. Not only in India, in US also, people are using this kind of techniques for doing farming. In India, typically our focus is rice, and but uh, yeah, then there are system developed for this other corn also. Okay, so or sometimes in the cornfield there are these weeds that grow. Okay, so you have to remove these weeds. So that can be done using robotics. Okay, so if you can employ a robot, and the robot is basically made intelligent enough uh, to calculate the wheat growth rate. Okay, so it can compute. So if there are sensors, it can capture that what is the wheat height or the like its growth rate. And based on that, the robot will go to the appropriate position and then remove these weeds. Okay, so how to do that in an optimized fashion, so that you do not spend a lot of time and energy in removing weed that is not problematic to you, but only go to the problematic area and selectively do it. Because this kind of systems, it requires a lot of money also, right? If you employ a robot in the field, then that is going to consume a lot of money. Mm. So you cannot employ like 10 robots for a field. When the fields are very miles and miles, they are stretched over a very large region. So if you want to do it with a robot, then you have to take appropriate action at the appropriate time. If you consume your time and energy in taking like wrong decisions, then that will be good from the economic side. Okay. So one of the major challenges in building a prototype and validating. Okay, so sometimes like pen and paper, you can propose solutions that looks good, but on the field, building them and then validating them, that is a very big challenge, because of the thing that, as I was telling you, that limited availability of public data is a problem, right? So this is the problem, that The public data which is available is limited, and sometimes they are they are not very they're not very trustworthy also, because uh, they may be captured using some device which is not very accurate, or sensors may not have very accuracy. So those kind of issues are there. Okay, so IoT based solutions. In this paper, precision farming is considered. Precision farming means doing this cultivation practices in an appropriate time, like this this your harvesting, and then harvesting, and then you're producing, applying fertilizer, all these problems. Okay, so here it has been defined as a multidisciplinary problem where information and technology management are interchanged together. Okay, so there are technology and then some information data is coming into picture, and then they exchange together. Okay, so Mm. One of the major problems in today's date is this. Sometimes there is insect attack. As you know that sometimes in the field there is an insect attack, and it has been found is a very difficult problem, because humidity and temperature, this kind of things, sometimes they have certain correlation, right? So if today my temperature is 25 degree, unless there is a huge rain or storm, then it may not it may be at the same level tomorrow also. Okay, so but pest attack, the insect attack, and these kind of issues are very difficult to handle because they are very random, and you do not know that which trajectory they will follow. Okay, so if you just follow the trajectory, if you just see, so sometimes in many places in India there is insect attack, and because of which lot of crop is wasted. But whenever some biological thing is involved, and it is very difficult to predict in which direction they will go. If it is predictable, then there could be some solution, like there are IoT sensors, and whenever it detects an insect attack, it can send a signal to the nearby fields. Okay, but that will not happen because they may go in a very different direction. So which is essentially some way of saying that there is a high amount of stochasticity involved, as I was saying. So in this kind of scenarios, model-free approaches might be useful because they can take into account high stochasticity in the system. Okay. The anomaly detection algorithms are also useful in a wireless sensor network. So in wireless sensor network, there are different sensors. Okay, the sensors might be actually communicating with them in a communicating with each other in a distributed fashion, or there can be a centralized server, which is, or one of them can serve as a leader, another can become follower. So this is called leader follower algorithm. So in this way, you detect the anomaly and agricultural activities. In another paper, that the authors have discussed different automation methods for elements using IoT and deep learning. So obviously, deep learning is also very useful. So in IoT, if you just implement some IoT devices, if you implement certain deep learning algorithms, then using those algorithms, you can find out what kind of actions need to be chosen over the field and so on. Okay. And concepts such as artificial neural network, backpropagation, pattern classification, fuzzy logic, these are also applied. So if you are looking for working in agricultural IoT kind of scenarios, machine learning is definitely one of the tool that you should be looking for, and concepts such as artificial neural network propagation, reinforcement learning, those will be very useful in practice. Okay, so IoT-based solutions is like it uses K-means algorithm, which is a well-known well-known machine learning to guarantee certain end-to-end quality of service guarantee in a wireless sensor network. Okay, and there are many suitability of different wireless technology is also one thing that we need to capture. That what should be the technology that I am going to choose, as I was saying in the beginning. Okay, so there are many technologies like narrowband IoT, wireless sensor network, Zigbee. So which network, which technology is appropriate for your use case? That is also a good thing. So if you want to have a brief overview of this, you can visit this paper. Um, and you review of different machine learning techniques such as linear regression, fuzzy logic, hidden Markov model, support vector machine. These are some of the techniques that are useful within the supervised and unsupervised machine learning techniques, and these are also useful in the precision farming. So one of the proposed solutions which can be done is basically you deploy different IoT sensors overall throughout the field. It will collect data and it will send to some centralized location. The data is analyzed and uh, then the action is chosen. Okay. So as someone was asking in the chat that does it need to be done in a everyday fashion? The thing is the decision making need not be a action of the farmer. The decision making is basically the action of a person who is capable enough to run algorithms and analyze the data. But the final thing has to be done by the farmer or the persons employed by him who will go to the field and do the operations. But analysis of data needs to be done by some expert. Okay. So, rather than spending money in employing lot of persons who will go to the field and do some agricultural activities, it is a wise decision to spend some of the money to a person who can actually help in doing this, who has the knowledge of machine learning algorithms and who can take an intelligent decision. Okay. So it can be centralized and distributed also. So by centralized, I mean there is a centralized server where the decision is made. As I was saying, that there can be a person who is a machine learning expert. Also, it can be fully distributed, which does not require any human intervention. Okay, so for example, it will just, for example, there are distributed sensors in the field, and whenever a sensor detects certain problem in the field, it will report to the other sensors, and then there can be a smartphone to the all of the farmers who nowadays they use smartphone. So if there is any app which can directly interact with these sensors, then he can get a notification on its phone that okay, something is wrong. Okay, but distributed approaches typically have their own problems because when you are making it fully autonomous, then also if something goes wrong, then it is very difficult to handle. So therefore, a combination of distributed and centralized is a good solution, and also a combination of model-based ML, model-free ML is also good because model-based ML helps you if there is some previous data available to you, although it might be of a high less reliability, but you can build certain model which may not be very appropriate, but it will serve as a guidance to you for making more refined model. Using model based machine learning, you can build a rough model and then improve over it by using model free ML. Okay, so this is like more refinement. So model based and model free can be done together. Limitations, some of the limitations of these proposed solutions is computational complexity of the machine learning algorithms might be very high. Okay, so if the computational complexity is very high and if they are running on the small IoT sensors, right, these IoT sensors will have very less computational capability. Their power is also very less. Okay, so those are the issues that if you deploy IoT sensors in the field, who is going to power them? Okay, so you need to devise algorithms which are very low cost, or some protocol which does not require the IoT to send data again and again, then the battery will be over soon. So as you have seen, this NB-IoT and this kind of solutions, typically these sensors, they can operate for years with a small battery. So those kind of sensors, NB-IoT sensors might be very useful. And if you are sending data every couple of days or something, then that would be decent enough for a sensor to live for a long time. Okay. So this is a thing. And second thing is, if some of the sensors are dying out in the field, it is very difficult to monitor them also, right? Because you can sort of deploy a sensor in a small hut near the inside the field, or a tree. Okay, so it is very difficult to manually go and charge them, or monitor them if they are out of charge. Those kind of limitations are there. Okay, and also there are issues such as communication band. For example, if you are choosing NB-IoT or you are choosing in LTE-M, okay, then you are basically operating in the license spectrum. But in the license spectrum, you may not have the permission to transmission. So therefore, you need a agreement with the cellular provider to do that. On the other hand, if you go for unlicensed frequency, then it may be better. Okay. So depending on the use cases, you have to select the appropriate technology. Okay. So to conclude, we have talked about AI-based solutions today and IoT-based solutions as well, and a combination of both, hand-in-hand combination of both makes the precision farming easier. There can be drone-based solutions also for areas where there is no cellular coverage or no IoT sensors deployment is problematic. So precision farming deals with appropriate time for irrigation harvesting, and also pest control is another issue, or one of the open problems in this area is how to predict the trajectory of the insects. Okay. So the insect attack, how to trajectory, how to predict the trajectory, and how to build algorithms to counteract insect attack. That is one of the most open problems in this area. Okay, with this, I thank you. These are some of the references. If you have any questions, I can take these questions.
Thank you, sir. Thank you for your nice presentation. So now I request the participants to please post their questions in the chat section or in the Q&A section. Or you can also raise your hand so that we can unmute you and you can speak in the session. Sir, Gulab Patel is one participant who has raised his hand. Sir, can I unmute him, sir?
Yes, yes, please.
Yeah, sure. Please give me some time and
Hi, good morning, sir.
Good morning.
Yeah, sir, distributed machine learning means we are training the different model in the different server or cluster or devices, whatever you say, or we are training the same model in the different server.
So by distributed machine learning, what I mean is basically there are these sensors, no? These are present in a
Yeah,
distributed
yes.
machine. So each of these sensors will run an algorithm in its device. So basically, algorithms will run at all of these sensors individually, not like at a centralized place.
Okay, so those are different algorithms, right? Not a single one, not the same.
Yeah, it can be a single algorithm only. For example, you are collecting data and building a model, right?
Okay,
So
okay,
now
I
what
just wanted to relate it whether it's same as a federated learning or both are different. Like in federated learning, what we do, we distribute the model in the different servers and then do the training and then combine it.
yeah. It can be something of that sort, or it can be basically it can be one. So what you are saying is one way. Another way could be, for example, there are 10 sensors and each of them are running the same algorithm. At the end of the day, they communicate with each other and verify whether
Final result.
the solutions that they have obtained is same. So it's basically kind of some averaging or consensus.
Okay, okay, got it, sir. Sir, can you go to the conclusion slide?
Yes,
Yeah.
yes.
So,
Thank you.
Here for smart agriculture, so how only AI based solution work? Because ultimately, what I think IoT should be there, or at least drone should be there.
Uh,
Uh,
no, AI-based solution is one of the possibilities. Definitely, there are other possibilities as well. But AI, what is do is it is very easy to monitor the wide range of parameters. It can work for wide range of parameters because it will learn on its own. That's why I am focusing on machine
Okay,
learning.
okay. So because the way I'm thinking, because we know need at least IoT or drones to collect the data, then we can use ML algo to train the
Yes, yes,
model and come with the result, right?
exactly. That's what I'm saying.
Okay, sir, one more problem related to model-free approach, because for the first time I am hearing the name, that's why. So, uh, if we do not have any data, okay, and second thing, if we have some data related to our problem, okay, it's not exact data, maybe there are some noise or there are some typo, okay, but still it will help to get some result, right? Get some conclusion.
If you have some data with less reliability, then it can help you to build a for example, a very rough model. That's what I'm saying. That it may be inaccurate. That is a problem. Another thing is you can view it as inaccurate For example, if you just want to approximate, for example, this is the correct behavior. Suppose
Yes.
this is the correct behavior as a function of time, right? So this is your some f, this is your t. But with the machine learning, you get something like this, okay, which is a good approximation. It can be a linear. Suppose you have fitted a linear model, okay,
Yes.
but the actual thing does look. Now this refinement you can do using model, okay, on top of it. So you start with so for example, your optimal. So this is consider this as your set of all possible strategies, okay, and this is where your optimal thing lies. You start very close with this help of this model. This is your starting point, okay. So you're starting very close to the optimal thing so that you can go to the optimal very quickly. But if you do not have any model, then you can start here. So you are starting at very far point, so therefore it will take you very long amount of time or long amount of effort to reach there.
Yeah, yeah, that's what I'm talking about. Because if we have something to make a inference,
Yes.
that would really help us. Because if you do
Yeah,
not have any
definitely.
data, so we don't know how to take the decision, right?
Definitely,
Uh,
definitely. Yeah, that's what I'm saying. That a combination of machine learning, combination of data driven and model based and model free will be a good idea. Not the yeah. So model free will give you some deterministic thing. Model based will give you some deterministic nature, and then on top of it you can sort of yeah, change it little bit.
yeah, okay, okay, got it. Yeah, thank you so much, sir.
Some other questions in the chat. Is existing solution is applied to agricultural field, is it profitable? Yeah, existing solutions, I think already we have been tried out. There are multiple ventures also. I do not, yeah, there are multiple, recently there are multiple solutions for, I think IIT Kanpur also developed a certain solution recently for monitoring the soil health. You can check out that if there is a device, you can give the soil and then it will tell you within some specified time that what is the soil health. So these kind of solutions are being applied to agricultural field, and this is one of the major problem. If you want to do work in agriculture, your theory and practice might be very different. So yeah, these are some of the potential research issues in the future. Yes, so another question, would you suggest some research component in the IoT agriculture? I think the references, so this was a question from Gigi and Matthew. So I think the references that we have shared in the last slide, no, those I'll share the slide with you so you can go to these references. These are some of the new papers on IoT agriculture. Okay, so there is another question from Dr. V. Bapuji Valavuju to how Skynet IoT messaging platform useful and work. So I'm not familiar with the Skynet IoT messaging platform. So I am not familiar with this. Any other questions?
So there is no question anymore in the Q&A section. So I guess all the questions and queries have been answered, sir.
Yes.
So on behalf of the principal coordinator of this program, Professor Ratnajit Bhattacharya, sir, I thank you, sir, for coming on board and sharing your knowledge with us, sir. Thank you so much.
Thank you for inviting me, and thank you for conducting this nice FDP session.
Thank you, sir.
Goodbye.
Thank you. So dear participants, shortly we will start with our next session. Our next session will be taken by our next expert, Dr. Arijit Soor, sir. So, Arijit sir, can you hear us?
Yes, I can hear.
Sir, we are making you the presenter in the meeting, sir.
Okay. So should I say on the video?
Sir, you can share the slide so that we can see or not. Like.
Okay. Is it visible?
Yes, sir, it is absolutely visible, sir. So, dear participants, So before we start with this session, we will have a short introduction of our next speaker. Dr. Arijit Soor sir is an associate professor at Department of Computer Science and Engineering, Indian Institute of Technology, Guwahati. His research is mainly focused on deep learning approaches to solve different computer vision problems like image, video restoration, underwater vision, super resolution, satellite image segmentation, image translation, image stagnalysis, zero-shot learning, active learning, adversarial perturbation, human gait analysis, detection for osteoarthritis from X-ray images, and different ML-based approaches for adaptive video streaming in 5G environment. Dr. Soor has founded a research project lab named Multimedia Lab in Department of Computer Science and Engineering in 2012. Currently, 8 research scholars are pursuing their PhD work under his guidance, and 6 students have already graduated. Dr. Soor has co-authored 28 top-tier journal papers and 50 conference papers in different premier forums. So with this short introduction, I welcome you, sir, on this platform to deliver lecture number 13, IoT-based geohazard monitoring and early working systems using deep learning. Over to you, sir.
Okay, thank you very much for a very nice introduction. And I would like to thank the organizer for organizing such a timely and important topic on IoT and different applications. And my talk on this particularly in application areas of geohazards monitoring and detection, because as you know, that is a very important aspect. Even in a country like India, there's a lot of different natural and geographical varieties and diversities. We particular in this particular talk, we basically emphasized on the deep learning algorithm, which is a very recent development of machine learning. And nowadays, deep learning becoming a very popular on different fields, mainly like computer vision, natural language processing, big data analytics, and medical imaging, and any other different very important fields. So particularly in this talk, I've just now this I'll go to the presenting mode and I off my video. So when we discuss required will again. So just can. So is it visible? So
Yes, it is visible.
okay. So the main outlines of today's talk is we these are the huge topic, and we just touch upon an important concept. So main thing is that we try to understand what is the geohazards detection and monitoring, and some what is the in Indian context how this geohazards detection monitoring is important. Then we try to understand what is IoT kind of thing. You already have a very good introduction. Lot of different lectures already on IoT. I have not spent much time on IoT. Rather, I'm going to understand that how this machine learning or basically the deep learning thing is evolved in last few years, and then we try to understand a few possible or very important machine learning, mainly deep learning networks in this particular domain. And in third part, what we'll try to understand how actually this deep learning network or kind of machine learning techniques are going to use for this geohazards detection problem. And then finally, there is a very interesting thing that how you combine IoT and DL hypothetically not that much work already has been done. There's a new kind of field that the amalgamation of IoT and machine learning for this geohazards detection. So without any, let us introduce ourselves. I'm just, we are from a multimedia lab. My name is Arijit. I did my PhD from IIT Kharagpur and joined here at IIT Guwahati in 2009. And already in introduction, our major emphasis on this research currently is computer vision using machine learning or deep learning. So different fields like restoration, underwater, satellite image technology, zero shot learning. So these are the a few examples, and some sort of video communication also we are doing. Okay, so these are the my group. We are very much they are basically, without my group, I'm thankful to all these students so for doing such this kind of work. So these are some students who are already graduated from our lab. And currently we have a few BTech students, 11 and 4 MTech students, so working. So we have some publication. I'm not going to that much detail. So without losing any time, we go to that. So first of all, we try to understand what is geohazards. And you see that in general, geohazards meaning some sort of natural calamities or natural kind of disasters that include landslide, this earthquake, tsunami, sinkhole, flooding, etc. So you can say that it's a geographical event that has a potential to destroy the property and the human life. So, and in our country, it's like there is a lot of different diversities in nature, and we have a kind of Himalayan belt. We have hundreds of river, and there is a some sort of can say the some sort of in civilized thing in urbanization is going on. So these are the major bottleneck, major problems where this kind of geohazards may take place. So what I'm trying to say that geohazards is not only due to only natural calamities for our construction work. If we are some in scientific way or non-scientific way build some sort of urbanization kind of structure, then the geohazards may possible. So this we trying to find out some geohazards. What is the thing is like that a landslide. Now you can see the picture that how actually that is this a very you can say devastating kind of thing. So landslides where the debris separates from bedrock and the material slides rapidly down. So there is a different reason of this, and overstepping slope, removal of the vegetation, earthquakes. So that is the thing is that sometimes it's caused due to the natural phenomena. Sometimes we for our kind of technological development kind of thing. So that will be very much since a lot of technological development is going on, we have to be very careful about. Okay, so other things, this is sinkholes is a very dangerous kind of thing because there is a some sort of natural depression on the earth surface. So it can caused by a collapse of underlying rocks. If there is a loose rocks or the vacant place under some sort of rock, it is it can collapse sometimes. So there's groundwater pollution. This is one of the major problem in country like us, that there is a lot of rivers and coastal side and lot of pollution are being due to the this technological development, and we can say that unscientific way, or kind of we have to neglect these habitats, kind of synchronization of these natural things. So this is a severe effect. It can contaminate wells and communicate drinking water. There is a life loss. So these are the, and we all know the flood. These are the some places in India. In every year there is a lot of this kind of problem, and it can be stopped in proper building of prime dam in proper position, something. So so the thing is that the geohazards thing is a worldwide problem. It is not only in India, everywhere it is there. But we will try to understand the potential and the threats of geohazards in Indian context, so that we can understand the important and the what is the major responsibilities from that our technological advancement to stop it or to mitigate these problems. So I'm give you some example that of this. So first of all, I say that we have a diverse geological environment, and the geodynamics process is also very diverse. Okay, so our country faces different type of geohazards like earthquake, landslide, tsunami, glacial lake outburst floods, landslides, dammed lake out the burst floods. So you see that there is in Uttarakhand and in Himachal that there is a lot of this kind of problem happening in a very in past, in just few years we see such natural calamities there. So about 2% of the gross domestic product and 12% of the revenue is lost on the average annually due to these various disasters. So it is not only that the causal causality for this property, it is basically the loss of humanity, loss of lives. So you can say that approximately 59% of the land territory is affected by the earthquake. So if we can somehow make that some early some alarming system or early you can say detection mechanism for earthquake, there's a lot of research is going on to predict that. If we can predict the earthquake, it's a very tough problem, but still people are doing very nicely for coming last few years. Okay, so now we come to the northern part of the country, the Himalayan belt, that the geodynamically active. So there is a lot of things is going on. We are not the geologist or thing. These are the basic, you can say, the points or basic fields where this kind of. So Himalayan belt is one of our major thrust area, or where we put our emphasis mostly, that this and this is severely susceptible to the landslide and floods that we have seen in last couple of years. It increased and substantially. And our nature is also, you can see that the temperature worldwide is increasing, so that the water level is basically increasing due to the melting of the such glaciers, and something is going on. So due to this changing climatic condition, that's what I'm trying to say, rising population and unsafe development and urbanization practice, these are the basically the now the very recent problem that we are dealing with worldwide, that incidence is impact those geohazards and increasing. So now we really are in a position as a country or as a this kind of technological society that we have to come up with some sort of very well-structured and well-organized geohazards monitoring and detection system, as well as how to prevent this kind of natural disasters. Okay, so these are the basic motivation and how to mitigate, how to deal with it, the effective monitoring and forecasting of the geotechnical stability of the slopes of the great significance of preservation and mitigation of the slope geological disasters. So the basic understanding that this is the major thing of this today's talk is that we can prevent it, or we can we can at least detect it, that is there is a chance of landslide, there's a chance of flood, and we can evacuate some people from the potential positions or potential sites the flood, and we can save not only the human life but also a lot of property and property loss. So now, since we don't have much time, I just taken just a few pictures for internet and some very good papers, very recent papers. That now, what do you mean by detection and monitoring? Okay. So what do you mean by geohazards detection and monitoring? Now here you can see that this particular example, a landslide monitoring and early warning system, and is basically showing using the 5G internet, 5G IoT kind of technology. So here, what is the major thing is that this system monitors important indicators such as the three-dimensional surface displacement. That is one of the parameters. So the important thing, and that is some sort of geological, geospatial, or kind of sometimes geotemporal also is parameters. In this particular example, you can see the three-dimensional surface displacement is a parameter, and that can be measured, okay, using some sort of sensors, some time using some visual sensor. So some, you can say, you put some camera on a drone, and this drone can go in a particular place where it is very tough for human to go and take snaps, and we put some very important sensor, inertial sensors, a lot of different sensors we can put. And again, some parameters which we can measure very easily, that means rainfall. Rainfall is one of the major aspects in this geological thing. Then ground cracks using global navigation satellite system. So another very important thing that we use there, that is the satellite image. In our group, we are working, two of ISRO students, they are doing PhD in our group. That we are very much working on different satellite images where we try to understand that flood detection, or kind of the water body detection from the satellite images. So there is a different aspect. If we go a bit and technically higher end, then we have to find the change detection kind of thing. Then the semantic segmentation for these satellite images to find out these observations. So these are the relevant fields and where we can put our efforts from a machine learning viewpoint, from Internet of Things viewpoints, and so on. So the key monitoring data are transmitted and displayed in 5G communication and advanced data visualization. So there is you can see there is a three important zone where we can put our technological advancement or technological research. Where is the 5G communication, satellite communication, then sensor-based monitoring and visual inspection kind of, and what we actually doing in the vision group. Okay, so these are the major things. Now I convert this particular lecture to bit going to machine learning or deep learning based techniques. That there is a that these geohazard studies, how from the machine learning point of view or deep learning point of view we can contribute. So now we, as you know, that if you have we nowadays all of us have some idea about these machine learning techniques like classification, regression, change abnormally, as anomaly detection, then spatiotemporal modeling and prediction. So these are the fields where machine learning algorithms and are very much successful. And now nowadays, just this using the when deep learning has come, that is for this kind of particular application, it outperforms most of the conventional machine learning. That we'll see mainly in this particular today's lecture, how actually why deep is become so much powerful. But before that, we'll try to understand the motivation of these machine learnings, or can say the machine deep learning algorithm to this kind of geohazards problem. So let's say classification. If we take that reclassifying maps, so there is a geographical maps. So how can we say that, okay, this particular area, if this kind of things are there, so it is susceptible for landslide. So this kind of classification is infrastructure damage classification. So when we take a satellite image or semi drone based kind of image, so this kind of aerial images, so we can get this infrastructure damage classification, classifying debris flow and the glacier. That is also a very important thing. Another thing I should here it is said that underwater geohazards, that is also because of tsunami and other underwater calamities. There is a lot of research scope is there, because underwater imaging is a very challenging job because of this uh, that due to the in underwater there is a lot of natural problems, is scattering, color effect. So then there is a very challenging to find the object detection, semantic segmentation, object classification, this kind of problem. So these are the lot of research people this still open for the image and video and computer vision based deep learning, using deep learning or machine learning algorithms. Coming to the regression, there is a landslide and debris flow that can be detected, and susceptibility flow susceptibility, sorry, and earthquake vulnerability, flood susceptibility, dot risk, this kind of thing. We these data actually how why it is called regression, because it is a kind of time sequence or time series data. So now just to look in a given a particular position or particular place, the in last few years or last 50 years, what is the data of this being flooded, or this being there is a lot of landslides kind of due to its natural uh, demographic kind of not demographic, it's a natural the characteristics, what is the land look like, land, what the characteristics of land, position of the river, and there is a so on rainfall. So these are the time series data that we can analyze, and we can say that we can predict that in this particular uh, time we should do this particular thing to prevent this. Then now another thing is very important, that you know that there is a lot of big barrages is there, where they are sometimes the time of the water, they basically release the water at a particular time. So this time management is also a lot of the adjacent villages are being flooded due to this barrage water. So that can be regulated to stop this kind. Now anomaly detection is that inventory compilation, either historical or immediate post event. So these are this kind of anomaly detection can be done, and prediction, and this prediction of specific geohazards. That means kind of I think you can say the flood, tsunami, and some landslide also. Estimation of movement, volume. Now that is also. Now one very important thing that we should say that and that this geographical structure actually it is also changing through time. So it is not that in this kind of geographical parameters, even in a particular land, that is also being changed. So there is also that the temporal change of a particular natural phenomenon. Some particular natural phenomenon is also very important. So this modeling, these things can be easily modeled with our very state of and recent techniques and this kind of. So it may be visual data. We generally work on visual data, but it is also possible some sensor data using some sort of big data analytics kind of thing. You can use some data mining techniques to handle this data. So okay, so this, I think this is the, you can understand what is the motivation of doing research in this field. So now we not 1 hour is very less time, so such a big topic. So I just done what is the evolve of deep learning over machine learning that we put in a very shortly. If in time permits, will go and some sort of cooperative networks. Okay, so that just coming to what is deep learning at this moment. So now you know these are the some stalwart machine learning or a deep learning kind of thing. So you know this Ian LeCun, Josh Benjo, and Nick Hinton got the Turing Award in 2020, and Andrew, everybody knows Andrew for his huge contribution in deep learning and machine learning. So by definition, what is deep learning? Deep learning allows the computational models that composed of multiple processing layers to learn representation of data with multiple level of abstraction. Now the question is that in this particular, this sentence is a very, very important to understand the efficacy of the deep learning over the conventional machine learning. So this next 10-15 minutes, we'll try to understand the meaning of this. Okay? And here it is, I just read out the sentence, but it is a very, very important, mostly which things is multiple processing layers. We'll see what is deep learning has been defined. And this is most important, learn representation of data with multiple layers of that is very important to understand, to realize why deep learning is so powerful and very popular nowadays for different fields of studies. Okay, so here that the difference between a conventional machine learning and deep learning. And so here you can see that in a conventional machine learning, even if you try to think from a geohazards viewpoint, that that an image, let's say image of the flooded area, you are trying to find out that this particular flooded area is flooded or not. You are detecting from a satellite. Now, in a normal natural where there is no flood, there is a number of water bodies, or there is a position that we have. And now, if this number of water bodies is increased, or the total area of the water bodies increased, that we can say that there is a flood. It's a very, very naive kind of detection problem. So, if this problems is given to a conventional machine learning thing, there is generally two things. One is kind of data processing that we technically say the feature extraction. So what do we mean by feature extraction? That given an image, we try to understand the different statistical or geometrical behavior or geometrical characterization of this image. Let's say for an image, if you say the image histogram is a first order statistics that we give some sort of global characteristics of the image. Okay, some sort of, and then you can say the high order norms or statistical norms to find out this. Sometimes it is been given that that if in a given, that's more easy example. You can say that if you are given a lot of images of cats and you have tried to find out a classified, you try to classify it's a cat and non-cat. So given an image, this your classifier will going to tell that a particular thing's cat or it's a non-cat, maybe dog or any other animals or anything, non-animals. So the idea is that what will be the feature? Generally, very intuitively, if you say that what is the colors of the cat, what is the size and shape of the cat, what are it has 4 legs, 1 tail, so something. So these are the basic features. That feature, what is the texture, how the texture is that, and so these are the feature by which we can describe, we can represent the cat. Okay, this is called the feature. In conventional machine learning, it was the job of the vision scientist who extract this feature depending on the application. Okay, it's a object detection or semantic segmentation or whatever, any kind of application. They engineering the features. That means they extract the feature. You can say hand engineering or manually extract the feature. And then they put a classifier, put this feature to the classifier. This classifier, you also note, it may be a logistic regression and logistic regression, or you can say support vector machine, if it's a neural net, anything you can put on that, and we can get a classification, is a car or not car. Now, this is the conventional setting. Now, if we go a deep learning kind of thing, these two things, this feature extraction and classification, this is, you can say, a kind of data part, and it's a network part. These two are somewhat cloud. Okay, so this thing, so it is that this feature extraction and classification done in a single. And what is the challenge? Now, one thing I should say here very categorically, that now there is a lot of misconception about deep learning research, that any problem, now deep learning is a black box. Now, any problem, any image or any video, any text, any kind of data, you put a deep learning and get an answer. It is, and so there is where is the research? What is the learning? What is the understanding? Now, this is very important, that the whoever new in this field, that the actual research or understanding is lies that this design of the network. Now what you have to do, you have to understand some sort of machine learning concept as well as computer vision concept, that how this network automatically, it's not a magic. It basically, we devise a particular network such a way that it can efficiently extract the feature. So that's why for a different application, the deep learning, and maybe you can say that there is a lot of existing deep learning, you can say, examples or a standard deep learning classifier. There, let's say the VGGNet, AlexNet, GoogleNet, ResNet. So why we are worrying about? But the ideal question is that they are there, they are written model, but you have to understand that how in a particular problem, if you put ResNet, you can get a result. But it is not actually, there a lot of can be improvement can be done if you do some sort of data processing on there, and some sort of put that different kind of things, that how you know the context, how you know the semantics, how you know the interrelate between semantic and concept. So for such a this kind of things, there's a lot of kind of things and new things that we have to understand from the vision as well as the machine learning. And there exactly the research lies. It is absolutely not a black box. So that is one of the major understanding of deep learning and in today's world. Now, if you coming to this particular problem, that that why deep learning is so much, you can say, powerful and so much you can say successful over conventional machine learning. That is one point, is that amount of that is very important to understand why deep learning is very much now you see this particular slide taken from the Andrew Ng's lecture. Now you can say that here this, if you increase the amount of data, then the deep learning performance after a certain threshold, you can say this particular threshold, this deep learning performance is going or started increasing. So now what happened now, my best? Now we are living in a world of information. It may be labeled, it may not be labeled, but we have a lot of information. And but if you just go back 20 years back, when we were the student at the university and IITs, and then we find getting data is a very important. Information is not that much available there. But nowadays, thanks to your different social media, thanks to your internet, thanks to your others media, so you can get a lot of information. Just then when we are was in school, then hardly very only the information source is our newspapers or radio. Even the TV is not that much popular, but very two channels in TV. But now you see how many channels in the TV, and we forget to see that this newspaper so much different news channels and online news channels and all these things are available. So we are so even in social media, you can see the lot of hundreds of thousands of images we are every day we encountered. So images and videos. So the thing is that if we use this huge, this is a very important thing, that if you use it properly, and then people that the scientific community or technological community that use this data very efficiently, that because one thing you have to understand, if it is the larger network for they required the data. Now you can say definitely, sir, it is from where data is available, but annotation. If in a supervised setting, annotation definitely. Annotation is a costly, very costly thing. And now there's a lot of companies that are coming up or already came up with, they are doing only annotations. So in supervised setting, annotation is one of the major aspect. But still, people now, even in the deep learning, they're going to unsupervised data or semi-supervised kind of approaches, so that we can get that annotation is not that much requirement. So the one primary aspect is availability of the data to deep learning becoming so much popular. So another few things. So here, and that is one example. I don't have much time, so that we can go in details. But just when I put that, that is one important aspect. Why deep learning is so much effective? Because what do you mean by deep learning? Deep learning is the natural, you can say, the multi-layer perceptron kind of thing. But number of layers is high. So number of layers means number of hidden layers is large. And then we have to try to understand what is the purpose of this. Now, in this example, we saw here we don't have much time. So it's I go a bit faster so that at least you understand the notion that this is a problem. This is a MNIST data set. It is US handwritten digit recognition system. And where we can put that, we have to recognize the digit given a particular handwritten, and what is the, it is a 7 or it's a 1 or something like that, or it's a 9 something. So what is this particular neuron doing? And you can see, if you see that we can take a just a horizontal line of this is a 9 or something handwritten digit, so we can get some 0 1 or some high response, low response output, input to this neuron. Okay, that your thing is not only horizontal, maybe it is a patch, 3 by 3 patch, something. Okay, so by this, what we'll see, that what is our general intuition said, that if you have to try to understand what is this particular numerals are, what we're trying to find out, we're trying to find out is the vertical lines. So one, if there is a vertical lines, it may be 1, it may be 7, it may be 9, something like that. Maybe horizontal line, that is some sort of 0, and 2 in the upper part of the 2, 7, upper part of the 7 is the horizontal line. There is a small circles in and 2, and then it's a 9, 6, and big circles in zeros. So these are the natural way, these are the kind of intuitive way to recognize these patterns. Okay. Now, what about the position of this? Now, question is that in this small circles 2 in lower part of this, but in the 6 lower part of the 2, but in 9 is the upper part. So localization of these naive patterns is a very important. Okay, so now the question is that you can see that these are the first neuron, second neuron, third neuron is at the is a row wise understanding. But how about position? You know the from where the response is coming from. So you can do one thing. In the second phase, this is the first level of your hidden layer. The next hidden layer, you can assimilate this, or can assimilate the verticals, assimilate this kind of, or combining these kind of you can say patches. So now you understand that why, if this they will going to give you some sort of positioning. So it is important to understand the role of hidden layers in that these hidden layers will going to give you some higher level of understanding. So that just recall the sentence we have read from this definition of the, that we are going to understand the different layer of abstraction, different information, or different layer in the information in a different layer of abstraction, hierarchical layers and hierarchical we are going to understand that. So this is the very important, that these layers, that multiple layer makes sense. But this is the so these multiple layers is really, we can go a very good understanding of this. If we go the face image, face recognition, now we are starting with a very just geometrical pattern like lines, curves, circles, something. And when the you can go the higher to higher layer, by this name geometrical pattern, you are going to make a pattern like a face, so that we can understand this face is given or this is not given, this is within it is not, and which face is this. So this is face recognition problems. So the idea is that the multiple layer makes sense. If you go to 100 layers, that is a very complicated pattern you can get. So the learning in the different layer of abstraction, when you go in a higher layer, you can get a higher level of abstraction. And that is the beauty, or that is the magic of deep learning. But you can see it is I don't have much time again. So I said that this fact is known to us from long back. Even this multi-layer perceptron is almost 30 years back. Now the question, what is not with us? We don't have a very good algorithm. In 2006, that particular thing is a layer-wise training kind of thing come, and there's a major breakthrough in this. So here we basically try to that layer-wise training means this in the first layer first, and this how we do the first layer, we say the kind of auto encoder. Okay, so we don't have much time, so we quickly go and that we skip all this and quickly go to the can understand that what is the basic understanding of geohazards is that. Okay. Okay, see this what is the now we can understand why deep learning is so much, and what is the difference between conventional machine learning and deep learning. Now we put what is the IoT and deep learning for geohazards detection. How this ML can be used for this kind of geohazard detection. Now you see that is first you need to know where we apply this for prediction. Okay, so use of machine learning and geohazard detection, you can say the object classification localization is a conventional machine learning problem that we can use hugely machine and deep learning application, deep learning model for this. But here you can say that art science task, this pattern classification, you can say the object recognition image, like the classification extreme weather pattern. Now you see that satellite image and find is there any kind of depression is started, the early prediction of any storm, any kind of cyclones, that is possible. So the pattern classification is one of the major thing that we generally do using this. So next it is that this is super resolution. So what do you mean by super resolution? This is also a field where there's a lot of research has already been done on machine learning, deep learning. Still, it's an open field. That a lot of things can be done on super resolution. But how you put in a geohazards thing? Now, the statistical downscaling and blending kind of problem. Super resolution application related to statistical downscaling climate model, so that you have a satellite image. Now, this satellite image that from that there is a, you can see there is a some sort of weather forecasting or kind of a pattern of cloud, but these are not, since it is a very high altitude they have been satellite, from satellite has been taken, you cannot understand that the resolution is not that much good there. So what you have to do, that you have to improve the resolution, so we make it much super, so you have to super resolve. So there is a lot of things. Another thing we are working on here, that satellite image super resolution. So just for example, you see that from now there is a lot of things in defense system. Now there is a some sort of, now there is a lot of things going on between Ukraine and Russia, and what this US and that this spy satellite are doing, they are exactly doing the same. They put they take these images, satellite images, and put some sort of image processing over there. So this kind of super resolution is one of the major aspects there, to find out what exactly they're doing. So from that altitude, it's very high altitude, when they are taking images, that the resolution is not that much good. So they put a lot of AI ML kind of techniques to do that. So these are every country is doing their border area. They do a surveillance kind of thing. So this is there is a lot of spy satellites and so there is a lot of things can be done there. Now you can say that this machine learning task that is called this video prediction kind of thing. So event detection, this is also a very important thing, that short-term forecast. Now it taken a satellite video, and how these basically clouds are basically originating from there. And not only that, another very important thing in kind of position in that this weather forecasting, and in land side also, if there is some problem, so you can use some sort of temporal data, so we can get some sort of, these are the potential threat or potential susceptible area of landslide that can be done to see this. So now this is a very recent paper where I put this is 2021, that that how deep learning application for landslide detection, these are that they, as the input, they use the pre landslide images, post landslide images, and some landslide images, and their output this kind of this spectral information, this deep learning that they use. So ideally what they use the change detection using pre and post landslide. So actually that how actually the problem, the after landslide, how the area is changed, or that how the land property of the land is changed. The objective, so object detection using spectral and spatial information, and objective detection by the applying of the only optical imagery data, transfer learning by using pre-trained models, so many. So okay. Then this particular slide where we put, this is a bit hypothetical kind of thing, that is important. Why? Because here we can see how this, maybe you can say this is a visual input. Now with visual input we can use a sensor data also, that what is basically from IoT sensor data. Now using these two things, now there is a data collection, this kind, you can say there's a data collection. One is sensor data, and use this sensor data, we can put some machine learning and conditioning factor, altitude profile, and curvature plan, and curvature slope aspect, slope angle, distance to river. Well, this kind of parametric information we can collect from these sensors. And again, there is the image data, that kind of, and these two data we can fuse. You can say that we have some image classification or kind of image or video-based visual data, and there is a sensor data. We can fuse these two kind of modalities. So so this is a multimodal. One is a sensor data, one is, and in a different kind of sensor, we have to use a data normalization kind of, and that is possible. Not that much work has still not been done in this. So it's a very good and recent field that where you can use your sensor data or this IoT based sensor data, and that will going to help your visual predictions or the visual based image based prediction, visual video based prediction. So this is this feature normalization, feature fusion, and then we have to try to put this feature, this kind of thing to the land and susceptibility. So it is possible to improve your vulnerability prediction. So almost we have no much time. So I try to conclude and put some future research in this domain. The application specific and complex deep learning based model for geohazards prediction. So it is important. Now most of the geohazards prediction based deep learning, I'm saying that they use there's a very standard model. They use AlexNet, they use GoogleNet, they use some kind of ResNet. But there is not that much research still people are doing, but we know that very explicitly designed for deep learning. For now, some satellite image there is some paper, but this geohazard, a lot of work can be done. Then use of higher temporal and multi-hazards database. So temporal data is very important. How naturally the lands or the characteristics of land is being changed. That is a lot of effect. There is a climate, that is rainfall, there's a lot of things. There is effect, the wind speed, that is wind direction in a particular position, the erosion, lot of things is there. So to find out. So understanding the consecutive events as the primary goal, that what are the that in a particular it is not that there is the event. So that is also that how to prevent, not only that, if something happened. Now how you do this kind of thing, that what kind of help, what kind of you can say that measure you have to take. So integration of physical models with data-driven models, that is very important. The physical models, there is some physical models are already established, even for flood detection, even for randomness detection and physical model. So can we use some data-driven model, means machine learning based or IoT based model? We can just make a combination of these. Handling online data and newer classes, and so that is also something we never, this kind of a land, we never see that this kind of land. What is the this is a completely different land. So some incremental learning can be, so some sort of domain adaptation, some sort of kind of zero sort learning, kind of incremental feature learning. So this kind of technique. So okay, with this I conclude this lecture. So I think, and thank you very much for your presence for this. So, and again, I thank the organizer. Thank you very much.
Sir, thank you for this wonderful presentation, sir. So,
Hmm.
dear participants, if you want to ask any questions, you can let us know in the chat section. You can post it in the Q&A section also, or else you can raise your hands. We will be unmuting you so that you can interact with the expert.
So any questions?
So, sir, there is no question in the chat section or in the Q&A section, sir.
Hmm.
So, I guess all the participants, they have no queries. So, sir, with this, we come to an end to the session, sir.
Okay.
Sir,
Okay, then thank you very much for this your
Thank you, sir.
invitation.
Thank you so much. So, on behalf of the principal coordinator of this program, Professor Ratnajit Bhattacharya, sir, thank you, sir, for accepting our invitation of E&ICT Academy and coming on board and sharing your knowledge with us and
Oh.
all the participants. Sir. Thank you so much, sir.
Thank you very much. Thank you. So I just log off. Okay.
Okay, sir. Thank you, sir. So, dear participants, with this, we come to an end to this session 1 of this faculty development program. So, shortly we will start with the session 2, which will be the hands-on session number 7. So, we will start by 12:30 onwards. So, we request all the participants to be online, freshen up within half an hour, and again resume by 12:30. Please don't disconnect your system. Thank you all. Good afternoon, everyone. Rishabh sir, can you hear me?
Yes, ma'am. I can hear you.
It's already 12:30, so I guess we can start. So dear participants, good afternoon, everyone, and welcome you all in this second session of day 8 of this 2 weeks long online faculty development program on Internet of Things and application in smart systems. This session will be carried out by Mr. Rishabh Kumar sir. So we will be looking towards the hands-on session 7. So over to you, Rishabh sir.
Okay. Thank you, ma'am. Good afternoon, everyone. So today we will be in this hands-on session, we will be doing on smart agriculture and irrigation. I guess my screen is visible to everyone.
Yes, it is visible. So dear participants, you can interact with the expert in the chat also, and in the Q&A section also. Over to you, sir. Thank you.
Okay, so in today's FDP on IoT and application smart systems, today's hands-on is IoT-based smart agriculture with automatic irrigation system. In this experiment, what we are going to do is like we will taking the parameters which are required for agriculture and irrigation purposes like temperature, humidity, moisture of the soil, and sending to a cloud service for monitoring as well as controlling a pump for irrigation purposes. So why we need this automatic irrigation thing? Because we all know that we earlier we always done irrigation with like a flood irrigation kind of thing where we just put continuously using our normal pumps and just put water and fill the landscape completely with water. But and after the introduction of the sprinkler, we are using sprinklers to irrigate the field or our land. But what happens, like there is an uneven water sprinkling. Let's say if we are using a rain gun or a drip irrigation method or a sprinkler method, then there is a high chances there one area can get more water, one area can get less water due to the unevenness of the landscape or the soil texture, or depending on the crop. Sometimes we have to give them a less water, sometimes the particular crop needs more water. So this balance need to be there. And also it with the lack of proper irrigation, the quality of the crops degrade, or and this will lead to the financial loss for the farmer also, and also degrades the quality of the end product. So for the smart, already people are using smart irrigation like in Unicorn Convert. We are also we are doing some of the project for irrigation. Like we are implementing LoRaWAN for wireless irrigation of a customer, where they can automate the whole process with the help of the smart irrigation devices. Even we developed a system for them that is called LCA, which is a low cost automation for agriculture uses. what it does, it takes care of all the fertigation, irrigation need based on a defined schedule programmed by the farmer, and it controls the valves for the sprinkler or rain gun, whatever they are utilizing. So there is a huge demand. Like from 3-4 years, we are shipping lot of devices for smart irrigation purposes. So here we will be using ESP8266 node MCU and a DHT11 sensor, and we will be also using a moisture sensor for sensing the moisture of the soil content. So I have two with me. I have 2 cups. They are filled with sand there, and one is a dry and another one is wet. And it will also consist of a water pump, but actually I don't have a water pump, so I have connected a relay which will use to operate a valve or a pump, and we can operate anything from that. So components used, first one is the node MCU with a ESP8266 chipset, soil moisture sensor, water pump module. We don't have here one right now. We have relay module. We have a DHT11, which is a digital humidity and temperature sensor, along with some connecting wires. So this will be first I will cover what is node MCU, what is ESP, features, and IoT connectivity for node MCU. I hope you all know. There is a question. No, we are not today. We will be not using a NPK sensor because NPK is most for the fertilization purposes. We are currently focusing on the irrigation itself. Okay, so this is the node MCU. I hope many of the participants are familiar with it. Can you, anyone from the chat in the chat box or the Q&A, they can confirm that they are already familiar with the node MCU, or have you ever used it before in some IoT projects? Because from the today onward, all the hands-on will be on this node MCU itself, on our node MCU IoT board. So this is the node MCU, and for the IoT application, this is a very great platform to start with. It has a ESP8266 chipset, and it has a wide variety of IOs like GPIOs, ADCs. It has a PWM support, and the best part about it that it's compatible with the Arduino IDE. So we don't need to learn a specific programming language, IDE or a language, or all the libraries or the projects that are compatible on the Arduino IDE, they are compatible to it. So this is a great feature what ESP8266 or node MCU brings, and it is very easy to use. It has all the peripherals like I2C, SPI, ADC, UART, one wire protocol, and many more. And the best thing is that we can use it as a Wi-Fi station mode or a AP mode. It can act as an access point or a station. Like it can act as a router also, and it can act as a device also. But in our today's scenario, we will be using it as a device. So what is ESP8266? ESP8266 is a chip which is inside this module. And it has a Wi-Fi capability. Now they have a new version that is ESP32, and it has a Wi-Fi with BLE. So it has both the Bluetooth and the Wi-Fi, but currently today we are using the only Wi-Fi version of it. Here are some of the readily available chips that versions that are available in the market, like with less in all the form factors, like they will come in like module based, the board based one. Like here you can see it's only 8 pin small size, where you can only get 2 GPIOs and a UART and a power and ground. And this like a small surface mount device base, where we can just solder it on a different board. And here are some of the versions of the ESP8266 that we are seeing here. And this is the pin out of the ESP12E chip. This is the module which is based on ESP8266 and which is used in many projects, and it is also used in the Node MCU. And there is a pin out here, the reset pin. It has only one ADC. The only downside of this chip is that it has a one ADC, and it's a single core processor. Whereas the ESP32, which is a newer version of chip, it has more IOs and it has more ADC channels. Like, because this one has only one ADC channel, and which can go only to 1 volt. Here is a whole board, and here is a chip, and it's a 32-bit RISC microprocessor inbuilt here, and which is like which can be clocked on 80 to 160 megahertz, and it supports free RTOS, and there is a 4 MB of external memory, and it has a 128 kilobyte of RAM inbuilt on the chip. The 4 MB memory is external. Actually, I can show where the memory is. Like here you can see on the ESP01, if you can see, there is a small chip. It's a SPI based 4 MB flash. On all the board, you can see a small chip with beside this ESP32 in every module. Like you can see a chip, because it doesn't have a flash memory for code. It has RAM, built-in RAM, but it doesn't have a flash memory. So ESP8266 is a SoC which have a processor and a Wi-Fi capability, Wi-Fi and analog front end embedded inside, with a RAM and some amount of boot memory. Then if we have to add an additional flash memory for our programs. So here are some of the space, like it can support JSON, XML, and even we can host a complete web page on the ESP12, like ESP32. These tiny modules can be like, they can act as a web server. If we want to make it as a small web server, we can make a ESP8266 to simulate as a web server also. And it is powered by 5 volt from a micro USB connector, and it can be also powered with a external power supply. We can give it like 5 volts, 6 volts, even max up to 9 volt it can handle, because it has this small LDO. It's the AMS 1117 regulator, which is used for conversion from 5 volt to 3.3 volt. So this SoC is a this module is 3.3 volt power as well, and 3.3 volt logic level. So sometimes there is questions with me like, what are we able to connect a 5 volt sensor to it? So technically, no. We either, if we are giving output to 5 volt system, then it is fine. If we are taking 5 volt input, then it is a problem for this module. So we have to convert it into 3.3 volt logic level. Then only it will accept. And it is relatively, it can go in the low power mode also, but it takes 80 milliamps at 3.3 volt for RF transmissions. Like for sending and receiving data, it takes around 80 milliamp. But we can put in the sleep mode, and then it will consume very less power, like a 2 amps, 3 amps is it can go. In a sleep mode, we can also go little lower. So any questions till now? If you have any questions or any doubt regarding this module, you can just write in the chat window. Or in a Q&A. So here you can see it is clearly that the GPIOs are not 5 volt tolerant. They would strictly to 3.3 volts. But in some microcontrollers like in STM32 and other microcontrollers made by other companies like from Microchip or HT, they make the IOs 5 volt tolerant. Means they can handle 5 volt. Even they cannot sync or they cannot source 5 volt, or they don't have they will always have a logic level of 3 volts, 3.3 volts, but still they are able to take an input of 5 volt. So without damaging the SoC or damaging the chip. So peripherals are here are some spec for the peripheral and the IOs. So it has a ADC, a 10-bit ADC, and it has a UART interface. So UART interface is also used for loading the code. It has a there. You can, if you can see, here is a small USB to TTL chip. In this case, it's a Cp2102. It's a small UART to USB bridge, and it is used for uploading the code in this module. And it has a PWM output also, so we can control control the dimming of LEDs, speed of motors. Like we can do PWM speed control also of a motor. And it has I2C, SPI and I2S interfaces. I2C and SPI is for digital communication, where SPI has a 4-wire interface, I2C is a 2-wire interface, and I2S is for sound interface. If we want to send sound signal via this digital protocol, we can use a I2S interface. And on board it has a reset button and a flash button along with a LED which is connected to D0 pin. So participant, any questions or any doubt? Please, if there are any, you please ask. And here what I'm mentioning, this is a Cp2102 chip. It is there. USB to TTL converter. It because we connect it via USB to our computer, and then it convert to TTL logic level and send data to UART. And then is with the help of this chip, we can communicate with this module and also program this module. And it also supports the flow control, because flow control is necessary for programming it. Like we will be using the RTS pin for programming this chip only, and also resetting it. And here is the pin configuration of node MCU. But there are very other board also. It's not only this node MCU. There are other models also available in the market. But overall, the pins are quite similar. Like the GPIO pin architecture is similar. Like on the pin 2, it has a ADC. Today, where we are going to connect our moisture sensor. And here are the spec for these node MCU. Like it has 17 GPIOs and all UART pins and I2C pin, everything. You can just look into it, because I already explained it to you. And here are the more specification. Like it's a RISC-based CPU and 3.3 volt input voltage is like 7 to 12 volt, but it can work from starting from 4.5 volt also, because the LDO is a kind of 1 volt drop. It's a, because the LDO they are using is the AMS 1117, which is a 3.1 1.5 volt drop. So anywhere from 5 volt it is good. So 5 to 12 it can handle, even it can handle more, but then it will start overheating, and it is not good for the chip also. And clock speed here, it is 80 megahertz. We can change the clock speed also, but from the Arduino IDE, it is kind of 80 na? And then there is a USB to TTL converter there, and the antenna is on the mouse itself, the PCB. It has a PCB antenna, like a microstrip antenna on the PCB. They already designed it, so we don't need any extra antenna. So why we are choosing ESP12V over ESP01? So ESP001 basically has less IUs. So because in today's product we will be using more IUs, and ESP01 has a less IUs, so we are not using it today. And another thing that we need a specific USB to TTL converter or any other board to program this one. But whether as the Node MCU has its own USB to TTL converter on board, so from where we can program it. And so here are the first step. This is kind of theory. So for adding the board, because natively the Arduino doesn't have this node MCU in its board section. So what we need to do is, like, we have to add it to the board manager URL. Then only we will be able to download it from the boards. So let me show you how we can do. So let's say we have to go in this. Let me show you. If we have this, if you have an initially Arduino setup, you will not able to see this in a board. Only you will able to see the Arduino AVR boards, and here are all the Arduino AVR boards. But you won't be able to see the other board. If you go in the board manager, they will only show the board which are listed from the Arduino, like for the Arduino AVR, Arduino Mega AVR, Arduino SAM board, and other boards, but Arduino Mbed OS. But they won't show you the ESP32 board or the other board. They are outside the ecosystem. Like here you can see I have ESP8266 board also. I have ESP32 board also, and also I have a STM F4 series, F1 series board also. So I have configured F1 also. But for doing this, what we need to do is, like, we have to I have to go in the files, then I have to go in the preferences, and here you can see, if you are able to see, I can not make it bigger. Like here you can see it is additional board URL manager. So how many of you have the Arduino already installed on your system? Can anybody confirm that they have Arduino already installed on the system? Okay, so if you don't have the Arduino, you can just go on the Arduino website. Let me show you. If you don't have Arduino, how to get the Arduino. You just need to type the Arduino. You have to go on the Arduino and download Arduino ID from the software, from the Arduino.cc. You have to go in the softwares, and from here you can just download it. There is another web version also which works good, but it won't. I haven't tried it for working with this Node MCU, so I cannot confirm whether it works or not for this. But for our normally Arduino platform thing, it works. But I highly recommend to download this Arduino IDE. So you have to download it for your platform. Like if you have a Windows 7, or newer, you can download Windows app. Also, you can download, and Linux, Mac OS, they have all. So if you don't have the Arduino, you can download it from here, from the Arduino website. And here you can see in the additional board manager, we have to put the URL which are given here. Like this is the URL that we need to paste here to get the board. So I already pasted it here. Is it visible? Because the font is very small. So is it visible to you or not? Can anybody from the audience can confirm if they are able to see this additional board URLs? Okay, so let me move forward. I haven't got any. Okay, I can post it in the chat itself. So I have pasted the URL in the chat itself. We have to put in the additional board manager URL. So let me show you once again how to do that. Go in this files, go in the preferences, because we are changing the preferences of the this IDE, and here we have to go in the additional board manager URL, and then we have to add the board. So once we added the board, we will go in the tools. Here we can see for edit is there, sketch is there, and we go in the tool. In the tool section, we will go in this board manager. There will be a board. This is how your look like. Let's say if your default is on the let's say. So here you will go, you will only see this. There is a board, there is a port, and get the board info, because I haven't connected any board with my system. So there is no COM port available. And now from the board, we have to go in the board manager first. And once you will go to the board manager, and then we have to type it here like ESP8266. If we type ESP8266, we will get this ESP8266 by ESP8266 community, and the latest version is 3.0.2, and it have all the boards like the VMOS, the Lolin board, the Olimex board, Node MCU version 0.9, version 1 also, which we are having. So it have all the board, and also the Spark Flood board, the Blink board. They have all the board there, and we just from here we just need to install. Because I already installed, they are not giving me the option of installing, but here you will see it will have an install button. So you just click on install, and it will take some time to install, like it will download all the board related data. So anyone in the participant have downloaded this, or ever are already worked on the Node MCU? Can some of you reply that you worked on the Node MCU or not worked on the Node MCU in the chat or Q&A?
Yes. Hello.
Yes.
Yeah, Jatina ma'am says yes, sir, in private chat.
Yeah, ma'am,
Okay.
I can see one. I can see.
Yeah.
So if you have any questions, you can also raise hand, I guess, and ma'am can unmute you so you can ask your question also directly.
Yeah, absolutely. We can unmute anybody who will be raising their hands in the meeting so that you can directly interact with the expert. Thank you.
Okay. Okay, so after downloading the board, it will take time because if you download any board, it will not take time, and it will depending on the our internet speed. It can be like in 5 minutes to 10 minutes to 20 minutes max out. So once we downloaded this board, I will be sharing this PPT also, but this part is crucial. You have to like see because if you after that session, if you have a board or a hands-on with Node MCU, so this is the basics of a Node MCU, how to work on the Node MCU, because the other two sessions will be also on the Node MCU itself. So from there, board manager, if we downloaded the board, then we will again go in the board, and here you will see the ESP8266. Now it will appear. Then we will go in the ESP8266, and then we will select the Node MCU version 1.0, which is a ESP12E module. So we will select it. So now our Node MCU is like ready. We can program our Node MCU. And here I just highlighted for you. It's in there in the PPT itself. If you want, you can use it. And this is how you install this ESP8266. I already shown you. So it is also mentioned in the PPT. So everything is there. If you want to look it later, you can definitely have to look at it. The PPT will be shared. But please try to focus in this hands-on session also, because if you have any doubts, then you can directly solve with me, like you can ask with me, because PPTs you can still have some doubts. And here is the circuit diagram. Like here is the simple circuit diagram. Here is our sensor, and here is the sensor module, because it's a capacitive kind of sensor. So we are converting it into an analog signal. Here we have a op amp which convert into analog signal as well as a digital signal also, like in binary 0 or 1, using a comparator system. Here is a small potentiometer. It is defined in the early next slide also, but I'm just telling you from here we are going to connect the analog pin to A0 of the node MCU, and we have a relay module which is used to run any water pump or any motor. We have a digital temperature humidity sensor which is again connected to our D3 pins. It's a single wire temperature and humidity sensor. So let me show you my hardware setup also via my camera then. Participants, are you able to see the setup? Okay, I think it's upside down. Are you able to see the board? Let me stop the screen sharing. I think that will be. Now I just stop the screen sharing. So here you can see if I show you, here is a relay module that I'm using for driving. It has two relays, but today we will be only using one. I have some sand with me, like I have one with which have water, another a dry one, and here is this sensor. If you are able to see, here is the sensor, that is a soil moisture sensor. It is dipped in this sand, and it's the module which converts it into the analog signal. And here we have a board. It's our Node MCU IoT development board, from where you can do a lots of hands-on, and I will be using most of the time for hands-on. Like we have, it has all the peripherals, like mostly it has 8 sensors. Uh, it has ultrasonic sensors, temperature, humidity. Here you can say it's on the board, and here is the Node MCU, and it has accelerometers also. It has OLED display, ultrasonic sensor, and air quality sensor also, and also a LDR sensor for light. But today only we are using okay, I will get this question. So let me explain the board first. I will answer this question, your question also, sir. So I think everybody is able to get the understanding of what the hardware I'm using. Okay, so here this is the Node MCU that already I shown you. It is the microcontroller which you are using for Wi-Fi and the programming also. And here is our soil moisture sensor. You can see this one, like this is the soil moisture sensor. It is we already have image. I have two cups. One is the wet one, another one is the dry. And here is the temperature humidity. The blue one is the temperature humidity sensor. And we have the relay module, which is used for controlling the motors. So this is the soil moisture sensor. Actually, yes, ma'am. For your question, motor specification. Actually, for the motor spec, ma'am, there is motor for the hobby purposes which are available in the market. Like they are small. I think it is mentioned in the slide here also. If I will go there. So we can just get a small motor from it has a small ½ inch or 1/4 of an inch for tube it supports, and we can do it for the experiment purposes. There's a small motors available. We can just give you link if you want, and from where we can purchase this hardware. This hardware you can purchase it from Uniconverge Robotics, UCT Robotics. Like from here you can purchase. This is our website for the boards. Actually, from here we sell all the hardwares that we have. They all are in-house designed. Like we have this IoT development board on which we are currently doing this experiment as well as other experiments also. Like other two hands-on will be on this. It is for the students. Like here you can see it has the Node MCU, ultrasonic sensor it have, OLED sensor it also has, MPU 6050 or digital accelerometer, compass, and gyroscope. Gyro sensor it is also there. Air quality sensor is there. LDR is here, and temperature humidity sensor is also here. So this board is listed on the website. So you can get the board from here. And for our participant, we own, this is the price for the outside. I think it's 1500 uh, price for this board. For in we sell to our student or FDP, any other people. We from directly we give it on a discounted of 1500 plus shipping. I think. So moving forward, here is the, you can see this is the soil moisture sensor.
Hello, Rish.
Yes, ma'am.
Yes.
Hello.
Please let us know in the chat.
Sorry, ma'am, I can't get it. I
Hello?
think, yes, ma'am. Ma'am, your voice is not audible to me. No, no, ma'am. So IoT development board is directly not compatible because the use for agriculture farm, because the motor can depend, like it can be a very small motor like in our household motor, which can be small, like it can be easily controlled with the relay. But for the farms, we have the bigger motors. So it completely need a different system to, like a proper motor control box or motor starter to operate. Like in a farm, if we have a bigger pump, like let's say if I have a 10 HP pump, 5 HP pump, which are very big, so they can be controlled from this board also, but we need an extra relays and contactors, these kind of things. But relays we need for basic our for our education purpose. We only need a relay module and a small motor. So yes, NPK sensor can be also interfaced with this board. You have to buy the sensor separately, and it can be if it is a digital sensor like with a SPI and I2C or UART interface, then it can be easily integrated with this board. Okay, so what is the smart, like if you have a smart garden kind of thing, so whatever, like we have to make, there is a, when I talk about the agriculture industry, because I worked I designed a lot of automation things for them also. So the earlier what they are doing, like they are doing like on the volumetric thing. What they do, they particularly decide that this portion of a land or this crop need this much water. Like they will decide that it will take 5 kiloliters of water, 5,000 liters or 10,000 liters. Then they decide what is the discharge rate of that pump, like 22,000 liters per hour. And then they decide, okay, I have to irrigate this one for 5 minutes, for 10 minutes, or for half an hour, for 1 hour or 2 hours. But they are not having any feedback system. Like already, let's say if there is a rain, so they have a system to measure that it has rained. So they will not complete, they will stop the system and it will not run. But what happens if the rain is only, so you don't have that like that what is the moisture content of the soil after the rain, and how much irrigation is needed. So that feedback is not in the system yet. So today we will be using this soil moisture sensor to build a feedback system, so that we know how much moisture is there and when we need to irrigate it or not. So this is how it works. It is a completely straightforward, and what it have is just a PCB. It's just a PCB with a exposed copper contact on the PCB trace, and which is coated in HAL like a hot air shoulder level. And the resistance, because it varies accordingly to the water content of the soil. The conductivity or the resistance of between these are because varies with the water content, the moisture content, and then it is picked up from these two. This is picked up and it is picked. The module just amplifies it, and there is a op amp which converts it into analog signal, and then it sends to our MCU. Because we cannot measure resistance, we can only measure voltage. Our MCUs always can make on the analog signal. We can only read voltages only, not current, not resistance, or not any other quantity. We have to convert in voltage to read from a microcontroller. If I want to measure a current also, then I have to pass it to from a current transformer and convert it to voltage, or I have to pass it through a shunt resistor and convert it to voltage and then to read. And the basic is the resistance is inversely proportional, because the more the moisture, the greater the conductivity of that particular soil is, and the lower the resistance between these two probes. So this is a theory and how it works. And if there is a less water, then there is a poor conductivity in the higher resistance. And the sensor produce output voltage according to the resistance. So we will be which by measuring we can determine the moisture level. And measuring the output voltage, we will be measuring how many like percentage. We will, if we divide this in a percentage, we can see that what percent of the moisture is there. Like it has 5% moisture, it has 10% moisture, 20% moisture, or so on. So this is a probe I already shown you. It's just a fork shaped one, and it has this exposed metal contact. It's a copper contact with a shoulder plating. Actually, it's because it's exposed copper. When the PCB is made, okay. So one question is like, one soil moisture can be used for how much area? If the area is leveled and it has only one irrigation source, then we only need one. We can use it one. But for like a larger area, we need more of these. Like it can be like we can, for a bigger land, we need lot of them. But if the ground is leveled and we have a irrigation system which works properly, so we don't need lot of them. If the level, like we have a proper leveled ground and we have a same crop, so we like I don't know the exact how much we will be needing, because it depends on the soil also and the structure of the land and also the crop we are growing. But we will be definitely needing more than that. Not only one is not enough for a big area. Like we can if we have 10 like if a big land, we can have a 10 of them, like for each, for one rain gun or one sprinkler we can have. And here is the module. Basically, it is just the sensitivity, like how is it sensitive, because it also gives you a digital data. Let's say if you only want to do a binary calculation, like you don't want to use any other microcontroller, you just straight want to use, like if it is below some this you and I have to send the data, then what it will be, we just adjust it to our desired level and it will give us the high and low output. And from this digital output, we can turn on any relay or any other thing also. But today, because we also have to send data to cloud, so we'll be using the analog mode only. But digital mode can also be used. So here are the theory, like how it works. It is present in the PPT. So I will not go again. There is a power LED which shows the that it is power, and here the status LED which gives you this digital, either it's crossing that threshold or it is under the threshold. So here is this module, and it first one pin is the A0, which is analog pin. Second one is the digital one. Third one is ground, and fourth is VCC. And here I'm using 3.3 volt as a VCC, and here it is all the specs. All the detail is mentioned, like analog supply voltage from 0 to VCC. It will swing from 0 to VCC. It will give you either 0 or 3.3. VCC is like 3.3 to 5 volt we can operate. Ground is our ground connection. And how to convert the analog, let's see how to, okay, sorry. Analog output of this, what we are doing, like we are putting this value into the ADC value. So we are using a ADC to convert it. So the analog output will be the ADC value divided by 1023, which is a kind of the full resolution 0 to full scale of our ADC register, because we have a 10-bit ADC inside this ESP8266, and here we can calculate the voltage. So, and for calculating the soil moisture, we have to subtract it from 100, and this analog output multiplying by 100, we will get the exact moisture percentage. Like if it is a very wet, then it will be 100, like it has the maximum conductivity. And if it is a very dry one, it has like 0. So how I can explain that. If you want to know that how ADC work, I can also explain. But I think all of you know that how ADC works. But basically, what it does, it samples the signal and holds the value and convert into the digital value. It takes the analog value and it has the steps. Like in this 10-bit ADC, it has 102 steps. 1024 steps it has from 0 to full scale. From 0 to 3 volt, it has 0 to 1023 steps. So based on the voltage level, it will give us a digital data. So here is the code for the soil moisture percentage sensing. So I will be showing you how to sense a soil moisture percentage from now here. So we will go in our Arduino IDE. Let me open the code. I will be sharing this code with you also. So here is the code. It is a very simple code. Like I just only specified that my sensor pin is A0 and I'm using a serial communication. I will be printing this on my PC for the serial communication to show the percentage of humidity. Moisture. I'm mistaking humidity different. I will be printing moisture. So it's in the loop. What I'm doing, I'm just taking this value and I'm reading this analog read voltage of the pin on the pin, and I'm just analog reading and putting in the formula and just printing it. So I'm sent, and then I have a delay of 1 second. So every 1 second I'm sensing a value. So let me connect my board. I just connected the board. Then from the tools, I have to check for the COM ports. If you are not able to get the COM port, you have to install the driver. And if you have many COM port, you are confused that which COM port to use, then simply go in device manager. You have to go in the device manager, and here in the COM port section, you have to see, because our node MCU uses the Cp2102 USB to UART bridge. So and it's from the Silicon Lab. The chip manufacturer is Silicon Lab. So you will see this. Then you will recognize this is the node MCU. Okay, so I will show you the like weather prediction. I will show. I have a use case we are doing for Hyderabad, or our outer ring road Hyderabad project, and where we are irrigating 200 kilometers of land via our devices, and we have a proper system. I will in the end of this session I will show you that also, that how we are using weather data and other data to do the irrigation. So from here we confirm that it is COM3, and I have selected the COM3 also. Here the COM3 is selected. Then first I need to verify this, that it is compiling correctly. Basically it's compiled. So now compiling is done. You can see if I pull the logs, and like it is showing because I enabled the verbose for this, then it is showing this, that it is using this much RAM, this much ROM, and this much data. But on if you haven't, then it will only show this, the white ones, not the red ones. So now I need to upload it. So I have to click on the upload. And now it is uploading. Now it just reset. Now it uploaded and reset. You can see that it all like it detected all the things, like it detects the chipset in the ESP8266. It has a feature, the Wi-Fi crystal is 26 megahertz, and it also detected the MAC, because for any Wi-Fi or any device which connects to internet need to have a MAC ID. So this is and also detected that it has a 4 megabyte of flash memory, which is connected via the SPI, and it just uploads the data on these addresses, and then it just reset it. And if I go in my serial monitor, and because my baud rate is 9600, if I switch to 9600, so code will be shared after this session. And now you can see there is like I'm getting 8% of a moisture. So let me connect my camera. Okay. Here you can see I have the wet one and the dry one. I put in the dry one, and here is my connection. And on my already you are seeing my screen, but on my screen I'm getting this data. Are you able to see like, or should I turn off the screen sharing to show? Or is it visible now? So here is the board, and here I put in the dry one, and here I have the wet one. In the dry one, I'm getting this 8%. If you are able to see, I'm getting 8% soil moisture, and moisture percentage is 8. And if I change this, like I take out the probe, I change to wet one. Now see, now it's gone to 72, 73% because it is wet. Let me show you. So now it is in the wet one. And you can see the data, like it is now coming 70%, 69%. So there is slightly variation because if we continuously read, there is some variation, but it is kind of accurate, like 69, 70. There is some error, but it is accurate to a point. So any questions till now, like about the setup of it, or you didn't understand and like what I explained? So you can ask, I can explain again. So now it is in the wet one. I'm getting this. And I put in the drive. Yes, sir. It is completely possible to train the controller with AI algorithms. We have one controller actually we that need extensive programming. Like what we did is like it has a 3,000, 4,000 lines of code, C code to run a proper controller, but that can easily be done with the AI also. But in later stage, there are also a lot of controllers from Israel and Italy that they use some kind of AI they are using to control the walls. They are getting the weather data, they are getting the temperature humidity data, they are getting the electric conductivity, moisture data. All this data they are getting, and on the based of the data, they are just scheduling the irrigation and fertilization. They all are scheduling by their own. Like they have a water budgeting feature from where they can auto adjust the water budget, like how much water they want to put in. Okay, so this is now the first step of the project we are done. Now we will be doing the cloud one, like how we will send the data to cloud. So let me explain about the DHT11 sensor. So DHT11 is a digital sensor for temperature and humidity sensing, and it is easily to interface with Arduino, Node MCU, ARM, and all of the thing. And basically, it is very readily available, and it has a good support. Like it has a good online support for codes, like it has the built-in library already available in the Arduino community. And what it does, it uses a thermistor, NTC thermistor for measuring the air temperature of the surrounding, and the capacitive humidity sensor for sensing the humidity. So here is the module. It looks like this. 10K. It has a bit on the data line. It has a 10K pull-up register because it only can pull it down. It cannot pull the line up. So we have to put a pull-up register. And here is the only sensor. Like it has 4 pin, but third one is not used. So VCC, it is from 3 to 5 volts. Ground is ground, and signal is for, if we put 3.3 volt, then the signal level will be 3.3 volt. If we put 5 volt, signal level will be 5 volts. And here are the specs, like 5% accuracy it have, plus minus 2 degrees Celsius accuracy in temperature, and it can be has a very small sampling rate. Like we can only sample it like 1 hertz once every second. But the recommended is to poll is a point half hertz, like a every 2 seconds. And it has a standard 0.1 inch pin pitch. And here is the inside of the temperature, this DHT11 sensor. Which controller can be used as of now? For this, Node MCU is we are using Node MCU, and Node MCU can be used for this project. And if you don't have Node MCU, for the soil moisture sensing, Arduino can be used, but we cannot send data to cloud. There will be a small problem there because it doesn't have the Wi-Fi connectivity. But no, we should have a Node MCU for this at least. So here is the NTC temperature sensor. NTC is a negative temperature coefficient, means the resistivity change. For training purposes, Node MCU can be used. Node MCU controller will be used because it has a good a very easy learning curve also, and it supports a lot of peripherals. And we can do like a lot of experiment on the Node MCU. Even on our board, we can do like a lot of experiments, our IoT board, because it already had a lot of sensors inbuilt. So here is the NTC. NTC is basically it's a resistor which changes its value with respect to temperature in negative side. We have PTCs also, which resistivity increases with the temperature, but but for temperature sensing, NTCs are used. And here is a humidity sensing component, which is a capacitive one. So it senses with the capacitive sensing. Then on the back of it, it's a small micro there, and which sends the data on the single pin. And now how to add a library. I will show how to add a DHT library on your Arduino, because we will be needing a DHT library to access the data. So in a library manager, we have to go and type DHT. Then we have to select the DHT sensor library and we have to install it. Like if I can show you, here I included the dht.h. To include it, I have to go in the sketch. Then I have to go in the include library. So because I already have a library, it will show up here. Like here, I can get see the library. But if you don't haven't installed, we have to go in the manage library. So we have to go in this manager. You have to click manage library. And I have to search for DHT. So here you see DHT sensor library. You can install in any one of these, but I found this by Adafruit. It is very good library and it supports all the functions. Because sometimes if you install the another one, they can have some error, but most of them work fine. But I always prefer this Adafruit one because they are the kind of a vendor to this Arduino community, and they are a big company, so we use their library only. So from here we have to click on the install because I already installed, so it is giving me the update option. But here you will find the install option like this. You will find the install option, so you have to click to install it, and the library will be installed. So next, today we will be using a ThingSpeak cloud platform for sending our temperature, humidity, and moisture data to cloud. So there is a small introduction about ThingSpeak. ThingSpeak actually is a cloud platform designed by MathWorks. So from here we can take our data also there, and also we can use the MATLAB tools to analyze it. If we want to do a very niche application, we can also do that. So here is this architecture IoT data flow. So there is the edge nodes, like in our case, our board is the edge node. Then there is the IoT platform, analytic IoT platform. Then there is a explanatory analysis or any other analysis you want to do. Then you can just send it to the edge gateway. This can be a person also. This can be a particular software also. So what is the IoT platform? It is a dashboard essential for visualizing IoT data and controlling IoT devices. Hardware IoT platform or hardware. It's also a hardware. It can be hardware, like if it is deployed on the edge, it can be a hardware, as well as it is a software when it is like in the cloud for managing out all the IoT devices, collecting data, storing data, visualizing, analyzing data from these devices. So there are a lot of them, like Things board is there, AWS IoT Core is there, Microsoft Azure is also there, Google IoT is also there. So there are a lot of platforms, but all of them are kind of paid services. But this ThinkSpeak is free to unlimited users, but after that it is also a paid one. So these are the IoT platform specs, like it should have to feature to collect data from different protocols and different network topologies. Like it should have support for HTTP, MQTT, COAP, and other protocols used in IoT, and also for the other network topologies. Like it should able to get data from a GSM or a LoRaWAN or Ethernet based or Wi-Fi based systems. And there is a device registry and management, from where we can manage the devices and also register new devices. Then there is a user and access management. So the user, from where we can assign a user, delete a user, uh, we can assign a role to a user, like what services or what features they can use. Then there will be reporting, like how we will get the alerts and notifications, and also rule engine for when we are getting from what parameters we have to get the alert or the notification will be defined in the rule engine. And there will be data representation, like visualization and business intelligence. There will be some component for the front end analytics, like graph charts, line graphs, gauges, and cloud based deployment. It should be a cloud based system, so it can be easily accessible and also scalable. And then there should be at least some sort of encryption, like at least SSL, TLS, or AES. Then it should support remote device configuration and control, uh, which is not there in this thing board itself. ThinkSpeak itself. And it should be scalable. Like it should be, if we are doing a lot of other things, uh, or doing like we have today we have 10 devices. Now we are moving to 30 devices or 1,000 devices. Then it should be scalable, and it should balance the load of the data, because once we have a lot of sensors, then there will be a huge data flow, and it should be customizable and also integrated with a third-party software. Like if we want to connect with some other intelligence software or the analytics software, it should be able to give to do that. So in the long run, it will be helpful. Like we can create a different for engineering team, we can have a more data-driven approach. For business team, we can have a different dashboard. So the tools are different. So this need to be connected to different softwares. And some of the cloud platform are like this ThingsWorks is from PTC, AWS, Google Cloud Platform, Element Blue, Sense IoT, IBM Watson, and ThinkSpeak. They are the platforms that provide the IoT cloud platform. So what is the ThinkSpeak? I will. So basically, it just sends receives data, and it gives a API. So today we will be using HTTP only, not MQTT, because I think MQTT is in the paid version of their software. So HTTP is in the free version of there. So today we will be using HTTP to send our data to this ThinkSpeak. So and we can analyze data in the MATLAB. ThinkSpeak have an integration for MATLAB, so we can analyze data MATLAB. So here is the architecture of small scale deployment. Like we can build a proper ThinkSpeak application like POC, smart devices. Here it is our devices. Then we will ingest, store data. Then we can compute it on the MATLAB. And basically it is for makers, hobbyists, and academics and engineers and scientists. For the industrial deployment, ThinkSpeak will not be very helpful because it lacks a lot of features. But for our purpose, training makers, for hobby purpose, for some research kind of work, it is good. So here is the dashboard, the ThinkSpeak dashboard, where we create the channels of the data what we want. And we have the private view, which we can see. We have the public view, which other people can see. Some of the example is like weather monitoring. And another one is the smart agriculture, to what we are doing today. So here you can see this is a simple dashboard on the ThinkSpeak. It having the wind direction, wind speed, and the location. So this kind of dashboard we can make, and then we can do some post processing using MATLAB analysis and visualization. And the advanced feature is like the same. We can use machine learning for anomaly detection using MATLAB. We can get the email alert of the performance changes and other thing, but they are in the paid version, not on the free. So now we will be moved to ThinkSpeak setup. So for the ThinkSpeak setup, we should have a ThinkSpeak account. So I will show you how to make a ThinkSpeak account. So please see this step, how to make your own ThinkSpeak ID. So we need to go to ThinkSpeak. So here you can see it says IoT Analytic Things, Peak Internet of Things. So we have to go to this URL. Because I already logged in, let me log it out. So if I go on the home page, you can see here, like it says start for free. So you have to click here to start. And then we have to create our account because we don't have an account. So we need to create, because I already have one. So I can just log in, but you have to click on create an account. So we have to put these details like our email ID, location, first name and last name to make our profile. So if is there any problems, or if you are not able to follow this step, you can ask. I can repeat once again. Please ask in the chat or Q&A thing, or that also reply if you are able to find this website and you are able to make an account. Like you have to put this email address, first name, last name, and hit continue. Then you have to use the email address again, and then it will verify your MathWorks account. It is already a MATLAB. MATLAB is also a product of the MathWorks. And then we have to verify our email. It will send a confirmation on the email, and then the profile is verified. And then the sign up will be successful. Then it will ask some question like for what purpose you are using. So for teaching and school student use, or whatever is shooting, you can just put there and you can hit OK. So I will give you 5 minutes to make your account. And on the same time, if you have any problem, you can ask the question. Oh, so I have anyone able to create their ThinkSpeak account? So let me log in my account. Please let me know if once you created the account. So once you have created this account, you will see this my channels, because I already created 2 channels here. So it is showing 2 channels, but we have to create a new channel. Channels are the like projects. Is anyone able to create the account? Okay, sir, I will repeat you. Process. So first we need to go to the ThinkSpeak website. We have to search for the ThinkSpeak. Then we have to go to the ThinkSpeak website, that is thinkspeak.com. Then we have to click on the get started for free. Then we have to create an account. We have to create an account. And then we have to put our email ID, our location, first name, last name, and then if it's a personal email, it will give you a error, like a warning, like you are using a personal matter, personal email ID, but you can just check the box and continue. Like if you are using Gmail ID or any ID, it will kind of give you this error, and then you have to click on the continue, and it will send you a confirmation message. Like this will be the confirmation message on the email. To verify your email, you have to click on the verify your email. So it will verify the email, and once the email is verified, it will just show that your profile was verified, and then you can continue it. Then you need to fill the password and hit continue. So it will make your profile, and it will give you this. This is the email ID, and sign up is successful. And then it will ask these questions, like for what purpose you are using, for teaching and research, personal, non-commercial process, because for commercial projects you have to purchase license. And this is the optional, like tell us something about your project. It's optional. If you want to put it there something, you can just write something, or you can just click OK. And now once you will do that, you will be on the new channels. So I hope you are able to make the account. So I can move forward to sending, designing a channel and collecting data. So anyone else is facing problem, or if you are facing any problem, do let me know. Okay, sir. So now thanks, sir. You created your ThinkSpeak account. So even if you don't have the hardware, you can still can able to create a ThinkSpeak account, and at least you will get a fair understanding of that how to use the ThinkSpeak as well. And once you can have the hardware, you can do this experiment also. Okay, so once we in this menu, then we have to click on new channel. So we have to give the channel name. So I'm putting smart irrigation project. Uh, uh, so that I can know. Then we can put a description. Project. Now we have to put the fields. So fields are the keys because it uses the HTTP. So fields are the key of the variables that we are going to update, and it's a super global variable. In the HTTP, it's a super global variable. So if I can show in the project, like you see I'm putting temperature, humidity, and these things are I have key. So we are sending this data using this key. So we have to label that field. That field 1 is the temperature, field 2 is humidity, field 3 is moisture. So we have to mention the fields. Like here you see field 1 is equal to now I will sending a moisture percentage, field 2 I will be sending temperature, on field 3 I will be sending humidity. So we have to make sure that the order is correct and we have the correct label. So field 1 is a moisture percentage, so I will put here soil moisture. Field 1 soil moisture, and we have to enable field 2, so I have to click on the enable field 2 and field 3 because we need 3 fields. On field 2 I have to put a temperature. Temperature is on the field 2, and on the field 3 it is humidity. So any questions now? And then we have to just click on save. We will not using any of these features right now. So we have to hit save channel. So we again we need to save the channel. We can also add the location, like we can show the location also on a map, and we also can put a GitHub or a link to external thing. But we are not doing this in this hands-on. We can, but you can do that. So if you have time, you can play with that. So here you can see we can add a visualization, add a widget, and export. And here you see I got 3 of the charts. First one is the soil moisture, temperature, and humidity. and I can create a more visualization. Like if I want to add a visualization, I can add. So it is mentioned in the PPT. And also I will tell you about the APIs key, but first let just see this one. So I can add a visualization. Let's say if I want to visualize something, like I want to visualize this temperature on a gauge. Let's say I want to add a gauge. So I just want to add a gauge. Sorry, it's in the widget. So in the widgets, I have to add a gauge. So I just now added a gauge, and then I have to name for the field one. Field one, and let's say field one is our, what is our field one? Field one is soil moisture. Soil moisture. So for field one, I just updated this, making this widget. So I will create the widget. You will see there is a widget, but it is because we are not sending any data. Here is this widget is not field value unavailable. So now what we are, and then we have to get the API key, because this is secured by the API key. API key is a key which tells that what this particular application to write on this application of ours, because it is only differentiated by the API key. Sorry, it is PPT. So make sure you put your API key, not my API key. Like here in the API key, I have a API key for write. Also, I have a API key for read. And here are the APIs. Like if you have a postman, if you have a postman in your laptop, you can just test these APIs. And you can put the fields and it will get updated. If you don't have the hardware, but today we have the hardware, so we may only writing, not reading. We are not reading any data, we are writing data. So we will just use the write API key. So I just using the write API key, and here is the code. This code will be shared with you, and I will also explain the code one to you. So what I'm doing, I'm just using a DHT sensor and a ESP8266 Wi-Fi. And here I'm putting the API key. So I just copied from there and I just paste here. So this is my API key, write API key. Is there any questions till now? And here is the server IP, which is api.thingspeak.com. And this is my Wi-Fi's use SSID, and this is my demo Wi-Fi password. And DHT is connected to D3, pin D3. Moisture is connected to A0. Relay is connected to D0. Interval is every 10 seconds. It will be sending a data, because the ThinkSpeak doesn't support a very fast update rate. So we have a serial is at 11.5200 speed baud rate, and then we are sending data. So I just pasted it here, and then I will just verify it. So if you have any questions till now, please ask. This code will be shared with you also. Anyone have any question on the steps? Sorry, this is the And now the sketch is compiled. I have to upload. Okay, sorry, I haven't. It is open in another window, so it's not getting permission. So now I just closed it. So I'm uploading up the code. And here is the we can make this channel public also, like it has a public view. If we make this channel public, then anyone with the URL can see this channel. For this, we have to do this sharing option. I will show you also. Now it is uploading and the upload is done. And here you can see soil moisture, it is printing a soil moisture. And moisture percentage is also, it is sending data sent to ThinkSpeak. It is sensing the moisture percentage, temperature 22, humidity is 91, and it's sent to ThinkSpeak. Now let's go to ThinkSpeak and you can see here you will see a data like here is the soil moisture, which is 11. Here is temperature, it is 22, because I have only one data point, then it is showing like this only, and humidity is 91. And here you can see on the gauge, it is slightly above 10, it is 11. And the relay is on. If I have to use my camera to show you, let me share this dashboard with you. I have to add a widget in this also. Let me add a widget. So we can create a public view as well as a private view. So here you can see there is two entries, two data points come, and here it is like 11. Humidity is constant, and temperature is like 22.2, and it is now 22.3. And the soil moisture is again, it is now we have three data. And here you can also see the data, like it updated 3 times. So don't, because it is an auto scaling graph, so that's why it's so seeing like that is a much a drop, but it is only a small fractional drop. We can just edit it also from here, like what is the all the data, like what will be the background, what will be the type, and it should be dynamic, and what is the title of x-axis, y-axis, what should be the time scale, average, all the things we can see, do it from here. So what I will do, I'm putting this link in the chat, in the chat box. Let me first check you, then I will. Yes, I'm able to see. So I'm putting this in the chat box, so you can see on your uh, screen also. So let me explain the code. So here we put our secret API key for writing. And here we put our SSID and password, and then we uploaded it. Then here is a private view, and here is the data. Okay, so let's go in the code. So if you go, here is the first setup one. I just started a serial begin, which means I started a serial at 115200 baud rate. Then I set a pin mode of motor pin to output, and then I put it digital write low for turning the motor off. Then I started DHT begin, and then I started the DHT sensor by calling the API, and then I connecting to Wi-Fi. So using this Wi-Fi begin function, I'm connecting to Wi-Fi. And if the Wi-Fi is connected, it's keep on printing dot till the Wi-Fi is connected. And if the Wi-Fi is connected, it prints Wi-Fi connected. Then the code goes in the loop. And here I'm using millis. I'm not using delay. I'm using millis to send data periodically to our server and also continuously monitor data. Also continuously monitoring data, moisture percentage, and turning the motor on and off. And then from this API, this function, I'm using the post. I'm posting this data to ThinkSpeak, and I'm making the packet and sending this data. So HTTP is like a session which is used for the web browser. Like it has the get, put, post, delete kind of functionality from which we can upload the data. So any questions? Are you able to see the dashboard that I'm sent? Please reply. I pasted the link in the chat. Can anyone confirm that they are able to see the dashboard? Please confirm if you are able to see this public view. Like I can add more, like let me add one more. Like I can add a temperature one also. Like field 2 is temperature. Let me check once to confirm. Yes, field 2 is temperature. Sorry, field 2 is moisture. I will let me add for the temperature also. So now you will see. Sorry, I just let me edit it. Temperature is field 2, sorry. And what we can do, like I can also add a range on which it can go red. Let's say I add a range for red. So from 0 to 30, it is red. Okay. From 30 to 60, kind of in the suboptimal area, I can add like, let me add a color. Let's say I add a green. Oh, sorry, yellow, not green. I add yellow, and then for 60 onward to 100, it is green because there should now there is a enough water. It is green. Okay, so now you see because the moisture is low, it is in the red zone. Can anyone in the participant confirm that they are able to see the project view? I shared the link in the chat.
Hello. Sir, are you there?
Yes, ma'am.
Yeah, the link which you have shared, it has been privately to the host. So I request you please share it with everyone.
Oh, sorry. Actually, I missed it. Actually, I've sent to all attendees.
Yeah, absolutely.
Okay, sorry,
Thank you.
sorry. All actually I send it to host only. There is a host. So now I shared a public link. Please go there and check if you are able to see this dashboard. So anyone from the participant can confirm they at least they are able to see. Okay. So thanks everyone that you reply for your reply that yes, sir. Okay, good. You are able to see the dashboard. So now I will show with the video like what is happening. I will start my video. I'm pausing the screen because I think the screen is already visible to you. I shared the uh, this one. Uh, okay, so here I have two cups. One is wet, another was it dry. In the dry there is 10 humidity and the relay is on. You can see the light on the relay is glowing, relay is on, and this is sending data to my cloud platform. Here in the public view it is sending data, the temperature data, moisture data. Sorry, miss, actually it should be humidity. I just missed. So humidity data, moisture data, and there is also the chart for humidity, soil moisture, and temperature. Okay, so let me show you what happen if I just change from one probe to another. Let's say the irrigation started and pump is on. Because irrigation started, pump is on, and it reached the certain water level which it desired. So from this dry to it moved to wet. And now you heard a click and now the relay is off. There is no more light. Yeah. You see there is no more light. So the relay is off. And now after few seconds, it will update the data on the ThinkSpeak as well. Now you can see the soil moisture is updated. Now the soil moisture is 64 and the relay is off. So soil moisture is in this one and the relay is off. So the irrigation is stopped. And you can easily see on your dashboard. So I hope everybody is able to see the changes. Please confirm if you are able to see. So this is the hands-on way we are doing. Right now, sending our live sensor data to ThinkSpeak using Node MCU, our development board, and controlling a relay. Now, if you have any questions, you can ask me. I will show you that what we are doing currently now for the smart irrigation. Like we are one of the OEM for one of the major irrigation companies, and like we are manufacturing the products for them also. I will show you the products also. So like we have made them a smart irrigation setup where we are using a LoRa based device. Like we have a LoRa based base station and a remote station, and it controls the wire valves. So on the same time, if you have any question, please let me know that. So actually efficient. So I'm not actually a data science expert, so I cannot uh, uh, recommend that one because. But yes, you can try online. You can get the this one. Yes, we can download the data. We have you can check that from the MATLAB analysis and visualization. You can download the data also. Like here from here, we can export the data. Okay, we can import and export the data. So here is our irrigation setup. So this is our irrigation controller. They are the remote unit. They have a battery inbuilt with a solar charger, and this is a base station which have a LoRa base system here, and they both communicate via LoRa. And we are able to achieve 2 to 3 kilometers of a range. So this is one of our units. It's kind of a demo. I will show the real one also. And here is the latest project we are doing for the ORR Hyderabad drip irrigation automation. What we are doing, like it's a 5-phase project, and uh, on the side of a highway there are always a plantation. But what happened due to the lack of irrigation and lack of maintenance, they are not able to sustain and they all eventually die, and there is no proper irrigation system is there. Like in our cities, we also seen that there is a tanker which irrigate continuously, and there is a one person who using the hose or the pipe and he irrigates it. But the government wanted to make it a very automated one. So we done this whole project in collaboration with our irrigation OEM partner, which from whom we are OEM. So what we done, we have a 4G gateway and our LoRa based unit, and then we have a booster unit in case if we need to boost the signals. Then we have 3 remote units. So on each lane there is one remote unit which have 3 to 4 valves under there, which is used for drip irrigation. And then there are a lot of pump stations, because it's a 200 kilometers long project. And then we have a pump station and a dashboard. I will show you the dashboard also. And here are the some of the features, like it has the electricity cutoff, mains off sensing, resumption of a program, water level sensing, validity for the same day. It has a pressure sensor, so diagnostics uh, like either the pipeline is choked or a pipeline is burst. either it is rain and then a rain sensor, or is there any rain or not. And then we have a flow sensor integrated to sense that how much water we are consuming every day. And we have a graphical chart for water consumption also. And here are some of the devices that we shipped. We shipped more than 400 devices. So here is this project architecture. So here you can see we have a local or a static IP with internet. There is a dashboard. They have the SCADA system. Then we have our base unit with 4G gateways there, and then with the LoRa they are communicating to remote gateway. Here it is able to do the pump. It is turning on the pump. It is reading flow meter. It is reading pressure sensor, and it is reading rain sensor as well as level sensor. So it can detect whether the level of water is low, so it can turn off the irrigation and the level of water replenishes. And here is our internal architecture of our 4G cellular LoRa gateway. So here we are using a gateway, and with the RS-485 it is communicating to our 4 input 4 output LoRa wireless LoRa RS-485 base unit, which is sensing all the data and sending command to our LoRa base units. Also, we have a power supply and a built-in backup for battery and charger. So it has a battery backup also. And here is a practical deployment. So here is the practical deployment of it. Here is a lithium battery charger unit. Here we have a lithium battery with a charger. Here is our 4G gateway, and here is our here is our base unit, and they are the sensors inputs and power supply. And here is the power supply. And they are the remote nodes, they are the remote units. They have a solar panel and a lithium ion battery, and they control the DC valves, latches valve. So it can be put on the rain gun. This one is a rain gun. Here is another installation. This is the motor control panel because it has a bigger pump. So there is a motor control panel is here, and here is our unit. And here you will see our remote unit with these pipelines. Here there are the pipelines which is used to drip irrigate the system. Here are some more samples. Like here it is for the rain gun, and here it is for this own highway project. Here is our base unit with a booster unit there, and here's the pipeline with the valves. And here is the login and the dashboard that we designed. From here, there is 3 packages. So package 1, 2, 3. Sorry, package 1, 2, and 4. And this is the dashboard. So it has the programs. Here from here, we can see the pump is on, flow sensor, water sensor, what is the status of rain, hands-on and water budget. Also, here we got the map, and here we got the what are the valves, and what are the valves are scheduled. And if they are completed, then it will show you complete. And here we have the graph and also the water level. That tank is full or filling is initiated, or tank is empty. If the tank is empty, the water level will be low. So that's it for today. So if you have any questions, please feel free to ask. Let me show you one of the products that we designed for our irrigation portfolio. Let me show you. I have we have designed. I have with me. So this is a low cost automation irrigation product that we designed. It is a controller, irrigation controller. I think if you are able to see or not, it is showing all the data like date, time, and it is showing mains off because it is not connected to any power source, and we can program and we can control 4 valves from it with the irrigation as well as fertigation. We have to connect the valves here, like it takes, we will connect the valves here and it will just automatically with a schedule, it will automatically run the irrigation and the fertigation. So here's the one of the products which we designed for the company. So participant, any questions or doubts, please ask.
Hello. Hello.
Yeah, hello.
Am I audible?
Yes, ma'am.
Yeah. So, dear participants, in case if you want to ask any query, you can raise your hands. We will be unmuting you from the host side. So we request all the participants to please let us know your queries either in the chat section or Q&A section, or raise your hands for verbal communication with the expert. Thank you. So, sir, there is one participant, Koteshwar Rao, sir. So he has privately messaged that kindly share your mobile number and email in Telegram group.
Okay. So ma'am, you can share my email with them.
Yeah, you can. That's what you can do it from your side in the chat section.
Okay, okay, let me share my email ID. I shared my email with. So any other questions or query if you have?
Yeah, one more participant has asked in private message. Dr. A. Sebastian is saying that, right, sir, is the irrigation control unit you have designed, is it available for sale? What is the cost per unit?
Actually, it is we are the OEM of the product. We designed it, but the company which sells is a different company. It's a proper irrigation company which sells, and it is still not launched. It will be launched in April, not of for the end consumer, and the price will be decided by them. But it will be a very low cost because the whole project is a low cost automation one, and then. Okay, the one question is like why with good development in the smart irrigation, why not reach to not reach to practically to farmers. So we do reach to farmer. Actually, our partner company, which is the one of the leading irrigation company, they are designing product for the farmers. So this is not the only one product we design. We design multiple products for them to be farmers, and the farmers are using. We have multiple of these our wireless systems, and the other systems are deployed. Even we are deploying a filter for this drip irrigation flushing. For drip irrigation, there is a filter which is used for flushing, the filter need cleaning. So we have designed an auto backflush controller for that, which is automatically flushes the filter. So that is also reaching to the end user. So whom do you call? Okay, the another for board as attendee from the course of the UCT robotics. Okay, let me share you his number. It is Rohit. Sorry, it just said. So you can contact Rohit for the board. He will be handling all of this. Any other questions?
So I guess all the queries are being addressed. So thank you, Rishabh. Thank you so much for this wonderful presentation.
Thank you, ma'am.
Am I audible?
Yeah.
Yeah.
Thank you.
Yeah, one participant has raised his hand, RC Ramola. Sir, so I'm unmuting him so that he can interact with you. Okay, please give me some time. I'm unmuting him.
Okay.
Good afternoon. My
Yeah,
question is
RC.
yes,
Yeah,
yes.
good afternoon.
My question is like you said the platform you use 4G also. If we go for 5G, what are the advantages we have, and do you have means the you can say from technology wise or from the overall system wise, we have some advantages in 5G.
Yes, sir. So yes,
Uh,
sir, definitely the 5G has the advantage, but the 5G is not deployed and available yet to an end consumer.
Okay, but cost-wise, it will be in comparison to this will be higher or
Yeah, so it will be higher, but the benefit for the 5G is like we can have a specific application driven plans. Like here, I also get a 4G data plan also, but it is
yeah.
just a plan only. It doesn't provide me a low latency or a high priority internet connection. But for these, I can specify what the bandwidth, how much bandwidth I need, and how much latency and things are we need. So it will definitely better than 5G, but the problem is only the coverage, because what happened, like coverage is very low in this rural area. So
Okay,
there is a very high chance that even we don't get the 4Gs also. So that's why we use the LoRa for the end connectivity. Then 4G is for the middle backbone.
okay. Thank you.
One question is like which cloud is more suitable for this IoT? So any cloud like AWS and IBM Bluemix is more suitable like from my side. But for learning, ThinkSpeak have a lot of things. Like from ThinkSpeak, we can do more than enough.
Okay. Thank you, sir.
Okay.
Thank you so much, Ramola sir, for your query. So, dear participants, if you have any queries, please let us know. We will wait for another 1 minute and then we will wrap up the session of day 8 of the program. So, let us know if you ask questions in the chat or Q&A, or else you can hands interact. So I hope all the queries answered. So thank you, Ritesh sir, for joining today and making this day 8 of the program so successful. Thank you.
Okay, thanks, ma'am.
Am I audible? Yeah.
Yes, ma'am. Okay, thank you, ma'am.
So one more announcement is there.
Yes, ma'am.
Thank you. Thank you. So
Is there any more
announcement is there. So quiz 2. No, sir. No, sir.
Sorry, ma'am. Actually, your voice is a little breaking.
Hello. Can you hear me now?
Yes, ma'am. Yes, ma'am.
Yes, sir. Thank you, sir. Thank you for joining today and making the day 8 of the program so successful.
Yeah, thank you, ma'am. Thank you.
Thank you. Thank you. So, dear participants, there is an announcement from our end. So, tomorrow there will be quiz 2 from 2 p.m. onwards. So, we kindly request all of you to be available at that time because the quiz won't be rescheduled again. Okay, it will be active for only 1 hour. So, we request all the participants to be available during that duration. And we also request you to kindly note that attempting the quiz is more important because there is no passing criteria in the quiz. So that's a request from our end. Also, we request all the participants to have a final check on the attendance every day so that we can, in case if you have any query, we can solve it on day basis, everyday basis. So that's it from our end. So we thank all the participants for joining this program on day 8 and making the program successful. So tomorrow we will meet again by 10 o'clock. The meeting link will be same. So we request all the participants to be available from sharp 10 o'clock so that we can start the session. Thank you. Thank you all for joining. So now I request the participants to please disconnect from your end. The meeting link will be deactivated in another 2 minutes. Thank you all. Thank you all for joining.